Hello there and welcome to Life Beyond Seen, where curiosity settles down gently, the lights grow a little softer, and the strange corners of our world are explored without rushing to turn them into monsters, miracles, or movie trailers. Tonight, we're heading north, to cold grey water, long quiet winters, and a sea that has carried ships, secrets, storms, and stories for thousands of years. We're going to the Baltic Sea, and more specifically, to one curious patch of seafloor where a sonar image once showed something so odd that people around the world leaned closer to their screens and wondered, very reasonably, what on earth is that? The object became known as the Baltic Sea Anomaly, which sounds rather official, as if the sea itself filled out a form and filed a complaint. It was not discovered by a government mission or a secret research submarine. It was reported by a Swedish exploration group called Ocean X, while they were looking for shipwrecks in 2011. They were scanning the seafloor in the northern Baltic, in the Gulf of Bothnia between Sweden and Finland, when their sonar picked up a shape that did not look like an ordinary bump, slope, ridge or pile of stones. At least not at first glance. It appeared circular. It appeared large. It appeared strangely placed at the end of what some described as a long track or trail across the seabed. And because humans are humans, and because we do enjoy giving mystery a dramatic hat to wear, it did not take long before words like UFO, ancient ruin, secret weapon, crashed craft, lost civilization, and underwater base began drifting through the conversation like excited fish who had all had too much coffee. But before we swim too far ahead of ourselves, let's slow down a little. That is the whole point of this quiet space after all. We're not here to shout that the mystery is solved before the kettle has even boiled, and we're not here to declare that every strange shape at the bottom of the sea must be a spaceship, a temple, or the misplaced lid from some giant cosmic teapot. We are here to look gently, patiently, and with a bit of common sense tucked under the blanket, because the Baltic Sea Anomaly is interesting not only because of what it might be, but because of what it reveals about us. It shows how quickly a blurry image can become a legend. It shows how the ocean can turn ordinary geology into something that looks almost planned. It shows how difficult it is to investigate the seafloor when the water is dark, the equipment is limited, and the thing everyone wants to see clearly is sitting far below the surface, refusing politely to explain itself. So, before we begin properly, let me ask you something. Where are you listening from tonight? Are you somewhere near the sea, where the air smells faintly of salt or rain? Are you inland, far from any coastline, wrapped in the small familiar sounds of your room? And if you could send one question down into the deep Baltic water, one quiet question toward that strange object resting on the seabed, what would it be? Would you ask, "What are you?" Would you ask, "How long have you been there?" Or would you simply ask, "Are we making too much of you, dear little lump of mystery, as humans so often do?" If you find this sort of slow journey soothing, if you enjoy strange science, old mysteries, and the calm feeling of letting the world become a little wider before sleep, I would be very grateful if you gave the video a like and subscribed. It helps this small corner of quiet curiosity reach other listeners who might also enjoy drifting through deep water, strange discoveries, and unanswered questions without someone suddenly shouting over dramatic music. There will be no shouting here. The Baltic Sea is cold enough already. Now, settle in. Let your shoulders loosen. Let the room around you become simple. Whatever has been tugging at your thoughts today can wait for a while. The emails, the errands, the messages, the small unfinished tasks that gather like crumbs on a kitchen counter, they can all stay where they are. Tonight, we're going beneath the surface, down through greenish water and silt and silence, to a place where sonar waves once returned an image that looked just unusual enough to start a story. The Baltic Sea is not the biggest sea in the world, nor the deepest, nor the warmest, and it certainly does not behave like a tropical postcard. It is a northern sea, enclosed by land, bordered by countries with long winters, old ports, and coastlines shaped by ice and time. Its waters are brackish, meaning they are not fully salty like the open ocean and not fresh like a lake, but somewhere in between, as if the sea could not quite decide what kind of mood it was in. The Baltic has seen traders, warships, fishing boats, submarines and wrecks. Many wrecks, in fact. Its cold, low-oxygen conditions can preserve wooden ships in remarkable ways, which makes it a tempting place for divers and explorers who hope the next sonar pass might reveal something valuable, historic, or at the very least, interesting enough to justify all the fuel. This was the world Ocean X was working in when the Anomaly first appeared on Sonar. They were not hunting aliens, they were not searching for a doorway to another civilization. They were doing the more practical and still rather exciting work of looking for wrecks and objects on the seafloor. Sonar, in simple terms, is a way of seeing with sound. A device sends sound waves into the water. Those waves travel outward, hit surfaces and bounce back. By measuring the returning echoes, equipment can build a picture of what lies below. It is not the same as taking a photograph. It is not like switching on a lamp in your living room and seeing your chair, your book, and the sock you thought you lost last Tuesday. Sonar is interpretation. It is a map made from echoes. It can be extremely useful, but it can also be messy, distorted, incomplete, and occasionally very good at making a seabed lump look like it is trying to audition for a science fiction film. And that is important to remember from the beginning. The Baltic Sea anomaly became famous because of images, not because someone walked across the object in clear daylight, not because researchers hauled it onto a pier and said, well, this is definitely a mysterious machine, and also it needs a wash. The story began with sonar returns, with shapes formed from sound, with shadows and edges and strange-looking geometry in a place most of us will never see with our own eyes. When people saw the early images, many noticed that the feature seemed round, perhaps around 60 metres across according to the claims reported at the time. That is large enough to make the imagination sit up in bed. Large enough to compare with a ship, a structure or a crashed object. Large enough that if you are browsing the internet late at night, already 3 articles deep into unexplained mysteries, you may begin to feel that the seabed is personally trying to tell you something. The shape also seemed to have details that some viewers interpreted as unnatural. Straight lines, flat surfaces, a central depression or opening, a raised section, a long formation nearby that was described by some as a track, trail or runway. These descriptions made the story spread quickly. A circular object under the sea is one thing. A circular object that appears to sit at the end of a long mark on the seabed is another. That is the sort of detail that makes headlines feel very pleased with themselves. It invites a story. It says, perhaps something moved here. Perhaps something landed here. Perhaps something slid, crashed or was dragged. Of course, the seafloor can make tracks and ridges and lines in perfectly natural ways. Ice can scrape. Sediment can shift. Currents can shape. Glaciers can leave behind landforms that look surprisingly deliberate. But the human eye is a pattern-hunting creature. Give it a circle and a line in the dark, and it may start building a whole airport. The internet did what the internet does. It compared the image to the Millennium Falcon from Star Wars. It suggested secret Nazi technology, ancient buildings, meteorites, lost cities, and alien spacecraft. There were also quieter voices from geologists and marine experts who said that the object was probably a natural formation, possibly shaped by glacial activity, rock deposits, or the complicated history of the Baltic basin. But quiet voices rarely get to wear the biggest hat at the mystery parade. Probably a glacial deposit is sensible, but it does not leap from a thumbnail in quite the same way as sunken UFO found under Baltic Sea. One of these sounds like a research note. The other sounds like someone has just opened the door to a very expensive documentary. Still, the sensible explanation matters. The Baltic region has been heavily shaped by ice. During the last ice age, enormous glaciers covered much of northern Europe. They pressed down on the land, scraped across rock, carried stones, ground material into sediment, and left behind ridges, mounds, and scattered boulders as they retreated. When the ice melted, the landscape did not simply become the Baltic Sea overnight in some tidy little before and after reveal. It changed through stages, with water levels shifting, basins filling, land rising after the weight of ice was removed, and coastlines moving over time. The seafloor there is not a smooth, empty carpet. It is a record of pressure, movement, melting, and long physical processes. Nature, given enough time and ice, can produce shapes that look odd, regular, even suspicious. Anyone who's ever seen hexagonal basalt columns, round concretions, or stones split into clean-looking faces knows that nature does not always bother to look natural. And yet, even after hearing that, the Baltic Sea anomaly remains sticky in the mind. That is the right word for it, perhaps. Sticky. It clings to curiosity. It does not disappear as easily as some other internet mysteries because there is just enough there to keep people looking back. There was a real sonar image. There was a real expedition. There were real divers and samples and interviews. There were genuine questions about the quality of the data. There were claims of strange equipment failures near the site, though claims like that are difficult to verify and easy to inflate once a story becomes famous. There were samples reportedly brought up from the area that geologists identified as rocks such as granites, gneisses, sandstones, and a piece of basalt, materials that do not require aliens, ancient machines, or anything with blinking lights to explain. There were experts who found the images too unclear to support dramatic claims. There were also explorers who felt they had seen something unusual enough to deserve more attention. So the mystery did not settle neatly. It stayed there, hovering between the cold facts and the warm fog of speculation. That may be why the story works so well as a bedtime mystery. It is not a creature chasing anyone through the dark. It is not a curse, a monster, or a haunted doll sitting in a cupboard, which, frankly, is where haunted dolls should remain if they insist on being that theatrical. It is quieter than that. It is an object, or rather a feature, sitting on the bottom of a cold sea. It does not move, it does not speak, it does not demand belief. It simply appears strange in a set of images and waits while people argue above it. There is something peaceful about that, in a way. The world is full of mysteries that shout for attention, but this one rests in mud and water. Whether it is a glacial formation, a rock outcrop, a sonar distortion, a pile of sediment, or something more complicated, it reminds us that the Earth still contains places where certainty arrives slowly. Even now, with satellites overhead, maps in our pockets, and phones that can tell us the nearest place to buy noodles at 2 a.m, the seafloor remains difficult. The ocean hides things not because it is magical, but because water is heavy, dark, corrosive, and inconvenient. It is very good at making simple tasks expensive. On land, if you want to examine a strange rock, you can walk to it, photograph it, chip a sample, measure it, and perhaps sit beside it with a sandwich. Underwater, every step requires equipment, weather windows, trained divers or remotely operated vehicles, boats, permits, money, visibility, and a patient tolerance for things not going according to plan. The sea does not care about your content schedule. So when people ask why the Baltic Sea anomaly has not been fully explained to everyone's satisfaction, part of the answer is simple. Investigating underwater objects is hard. Investigating them well is even harder. A blurry sonar image can travel around the world in seconds. A careful marine geological survey takes time, money, and less exciting paperwork. The mystery spreads faster than the method, and once the public imagination has dressed a feature in the costume of a crashed flying saucer, it becomes surprisingly difficult to undress it again and say, there we are, probably just stone. But probably just stone is not an insult. Stone can be wonderful. Stone can carry the history of glaciers, pressure, minerals, ancient landscapes, and forces so slow that a human lifetime seems like a blink during a blink. A natural formation at the bottom of the Baltic Sea might not be a machine, but it can still be a message from the deep past. It can still tell us about ice sheets that once covered the land, about the way sediments moved, about how the Baltic basin formed, and about how easily the human mind turns partial information into a full story. In some ways, that is more interesting than a simple answer. A spaceship would be dramatic, yes, but it would also end the conversation rather quickly. After several governments arrived, several scientists looked overwhelmed, and someone inevitably tried to sell souvenir mugs. A natural mystery asks us to learn how the world works. It asks for patience. Still, it is easy to understand why the stranger theories caught on. Imagine being on a boat, far from shore, with screens glowing in the dim working light. The sonar sweeps across the seafloor, shapes appear and fade. Most of them are ordinary. Then suddenly something different shows up. A large round form. A shape that seems too neat. Something that does not immediately fit the categories in your mind. In that moment, before the cautious explanations arrive, before the experts weigh in, before the internet begins turning the image into a dozen different legends, there is a brief, clean feeling of discovery. Not proof, not certainty, just the feeling that the world has opened a small door and allowed you to look through. That feeling is powerful. It is the same feeling that has sent people into caves, across deserts, up mountains and down into shipwrecks. It is the small human voice that says, "Go closer. Tonight we will go closer, but gently." We will follow the story from that first sonar reading to the dives that came afterward. We will look at what people claim to see, what scientists thought was more likely, and why the Baltic seafloor is exactly the kind of place where a natural formation might masquerade as something built. We will talk about sonar, glacial geology, strange shapes, bad images, big claims, and the very human habit of seeing intention where there may only be erosion, sediment, and rock having a particularly dramatic afternoon. We will not mock the mystery, and we will not swallow every claim whole. Both are too easy. Instead, we will let the story breathe. Because the Baltic Sea anomaly is not just a question of what lies underwater. It is a question of how we respond when something does not make sense right away. Do we rush to the wildest answer? Do we dismiss it too quickly? Do we let wonder and skepticism sit in the same small boat without pushing either one overboard? That may be the best way to approach this object, whatever it is. With curiosity in one hand and caution in the other. A torch, perhaps, but not a trumpet. For now, picture the northern Baltic on a calm day. The sky is pale, the water is dark, not black exactly, but heavy with depth and distance. Somewhere below, sound waves move downward from a passing vessel, spread through the water, strike the seabed, and return as echoes. The machine listens, the screen draws, the explorers look, and in that ordinary act of scanning, something unusual appears, not clear enough to settle the matter, not meaningless enough to ignore, just strange enough to begin. And as the boat moves on above the cold water, the object remains where it was, silent under the Baltic Sea, covered by darkness, surrounded by silt, waiting for the first human interpretation to reach it from above. On the boat above the cold Baltic water, it probably did not feel like the beginning of an international mystery. Most discoveries do not announce themselves properly. They do not arrive with thunder, a glowing symbol, or a neatly written note that says, "Please pay attention, this will become very strange later." More often, they begin in a working moment. A screen is being watched, a line of data is moving, someone is tired, someone else is thinking about the weather, the fuel, the next scan, or whether the coffee on board has reached the stage where it is no longer a drink and has become a warning. That is one of the interesting things about the Baltic Sea anomaly. It was not found during a mission that set out to solve the unknown. It was found during a search for something much more ordinary, at least ordinary by the standards of people who spend their time looking for shipwrecks. The Ocean X team, led by Swedish explorers Peter Lindberg and Dennis Osberg, were scanning the seafloor in the Gulf of Bothnia, a northern arm of the Baltic Sea lying between Sweden and Finland. Their work involved treasure hunting, wreck searching, and salvage exploration. In that part of the world, this makes sense. The Baltic has a long history of shipping, trade, war, fishing, and storms. Its waters hold the remains of vessels that sank decades or centuries ago, sometimes preserved with surprising care by the cold, dark conditions below. For a team searching with sonar, every sweep of the seabed carried the small possibility of finding something valuable, historic, or simply unusual enough to justify a closer look. The sea there is not especially welcoming. It is not the blue, clear water of a holiday brochure, where a diver can look down and see sand, coral, and small fish, behaving like they have been hired by a tourism board. The Baltic is colder, darker, and more closed in. Its water is brackish, a mix of salt and fresh water. Visibility can be poor. The bottom may be covered with sediment, stones, ridges, and marks left by ice and currents. Even before a mystery enters the story, the setting is already difficult. The seafloor is not a clean table with objects laid out politely for inspection. It is more like an old attic where everything is covered, half hidden and oddly shaped, except the attic is underwater, 90 meters down, and does not allow you to simply turn on a ceiling light. So the team used sonar. Sonar is often described as seeing with sound, and that is a useful way to begin. A device sends sound pulses down into the water. These pulses spread out, strike the seabed or anything resting on it, and bounce back. The equipment measures the returning signals and turns them into an image. But that image is not a normal photograph. It is not a crisp picture taken with a camera. It is a record of echoes, shadows, angles, and surface changes. The sonar does not say, "Here is a rock, here is a wreck, here is a suspicious object wearing a little hat." It gives patterns. Human beings then interpret those patterns, and human beings, as we know, can be both brilliant and slightly overexcited when presented with a strange shape in the dark. A side-scan sonar image can be especially dramatic because it shows not only what reflects sound strongly, but also the shadows cast behind raised features. A small difference in height can look larger depending on angle. A rough patch may look structured. A slope may look like an edge. A cluster of stones can appear like one connected mass. The image can be affected by the instrument, the boat's movement, the distance from the bottom, the nature of the sediment, and the way the data is processed afterward. This does not mean sonar is unreliable. It is an important and powerful tool. It has found shipwrecks, mapped sea floors, supported rescue work, and helped scientists understand underwater landscapes. But like any tool, it needs context. A sonar image is a beginning, not a final verdict. It is a reason to ask better questions, not a permission slip to immediately build a museum around your favourite theory. Still, imagine the moment when the odd return appeared. Most of the time when people scan the seafloor, they see features that fit into familiar categories: a ridge, a depression, a rocky patch, a possible wreck, a line made by trawling gear, a mound, a scatter of stones. Then, in the middle of that expected underwater roughness, something appears that looks different. A broad form, a rounded outline, a shape that seems too large and too clean to ignore. On the sonar screen, the feature later associated with the Baltic Sea anomaly seemed circular, or at least circular enough for the mind to grab hold of it. Reports around the discovery described it as roughly 60 meters across, which is about the length of a large passenger aircraft, or a generous city block if the city planner had a taste for underwater puzzles. 60 meters is an awkward size for the imagination. If something is small, we can dismiss it as a stone, a log, or a bit of debris. If something is enormous, we tend to call it a hill, a ridge, or part of the landscape. But 60 meters sits in the middle. It is large enough to feel intentional, but not so large that it becomes automatically geological in the public mind. It is the sort of size that allows people to say, well, that could be something, and once the phrase, that could be something, enters the room, it sits down, gets comfortable, and begins ordering snacks. The reported shape was not the only detail that caught attention. The sonar data also appeared to show a long feature nearby, sometimes described as a track, trail, or drag mark leading toward or away from the object. This was the kind of detail that made the story much easier to tell. A circular shape on the seafloor is curious. A circular shape with a long mark beside it is practically begging to be turned into a scene. People imagined something sliding across the seabed, something landing, something crashing, something being dragged by a force or event that had happened long before anyone arrived with a boat and a sonar unit. The mind does not like loose pieces. It wants sequence. It wants cause and effect. It wants to take a circle and a line and turn them into an event. But the seafloor creates lines for many reasons. Ice can gouge and scrape. Ancient glaciers can move rock and sediment across landscapes with such force that their marks remain long after the ice itself has disappeared. Currents can shape sediment. Trawling can leave tracks. Geological structures can form ridges that point in a consistent direction. In an area shaped by glacial and post-glacial processes, a long mark does not automatically mean something travelled there like a vehicle arriving late to a meeting. It may simply mean the bottom has a history. Still, from the point of view of the people first looking at the image, the feature was different enough to deserve attention. There is a quiet tension in moments like that. A responsible explorer has to hold two thoughts at once. The first thought says, this may be important. The second says, this may be nothing unusual at all. Both can be true at the same time in the early stages. That is not failure. That is investigation. The problem begins when the first thought runs out of the room before the second has put its boots on. A mystery can move very quickly once it reaches the public, especially when there is an image attached. And this mystery had exactly the right kind of image. It was unclear but not empty. Strange but not impossible. Detailed enough to invite interpretation, but blurry enough to leave room for almost anything. The OceanX team had reason to be interested. They were experienced at searching underwater, and they knew that unusual sonar returns could lead to significant finds. A shipwreck, for example, may appear only as an odd shape at first. A pile of cargo can look like a mound. A broken hull can look like a natural ridge. The first scan rarely tells the full story, so seeing an object that appeared to have an unusual outline would have been exciting. Not necessarily because it was alien, ancient, or artificial, but because unusual things on the seafloor are worth checking. The sea has hidden enough real surprises that curiosity is not foolish. It is often how discoveries begin. At the same time, the early image did not allow for certainty. It was not clear enough to prove construction. It was not clear enough to show machinery, walls, doors, symbols, metal, or anything that could confidently be described as manufactured. What it showed was a feature. A strange feature, yes, but still a feature in a sonar image. That distinction matters. There is a difference between we have found an object that looks unusual and we have found something that should not exist. The second phrase is much more exciting, but it also asks for much more evidence. Extraordinary claims do not become impossible claims, but they do require stronger support. A fuzzy shape at the bottom of a sea can begin a question. It cannot by itself finish one. Even so, the story began to grow. The location alone helped. The Baltic Sea has a certain atmosphere in the imagination. It is northern, cold, historic, and full of old roots and old conflicts. It has seen merchant ships, warships, submarines, aircraft, and naval operations. If someone tells you that an odd object has been found under warm, shallow water near a tourist beach, the mind may go one way. If someone tells you it was found under the dark Baltic, between Sweden and Finland, in deep, cold water where wrecks can lie preserved for generations, the mind goes somewhere else. It becomes easier to imagine secrets. Not because secrets are the best explanation, but because the setting gives them a comfortable place to sit. The practical details also gave the discovery a certain weight. This was not just a rumour with no origin. There was a named team. There was a reported location. There were sonar images. The team spoke publicly about it. They returned to the site. Divers were involved later. Samples were discussed. Interviews appeared. For many listeners, that made the anomaly feel different from the usual collection of blurry lights in the sky or suspicious shapes on old photographs. It was underwater, mapped by equipment, and followed up by people who had actually been there. That does not automatically make the strangest interpretation correct, but it does make the case more persistent. It gives the story bones. The first reports also benefited from a simple visual comparison. Many people said the object resembled the Millennium Falcon from Star Wars. Once that comparison was made, it became almost impossible for the public not to see it. The human brain is very good at this. Show someone a vague shape, then tell them what it resembles, and suddenly the resemblance becomes stronger. A cloud becomes a rabbit, a stain becomes a face, a rock formation becomes a doorway, a sonar return becomes a spacecraft. This process, called Paridolia, is not a sign of stupidity. It is a normal feature of perception. Our brains evolved to detect patterns quickly. In daily life, this is useful. It helps us recognize faces, read expressions, notice danger, and find meaning in complex surroundings. But it also means we sometimes see structure where there may only be shadow, angle, and chance. The brain is not a camera. It is a storyteller with an excellent filing system and a slight weakness for drama. On board the exploration vessel, though, before the internet comparisons, before the tabloid headlines, before the theories piled up like coats on a chair, the discovery was still a technical puzzle. What had the sonar actually recorded? Was it a wreck, a natural outcrop, a formation left by glacial activity, a pile of rock, a distortion in the data? Could it be something man-made, perhaps a structure, equipment, or wartime debris? The Baltic Sea has enough human history beneath its surface that not every artificial explanation has to involve visitors from another planet. Mines, cables, wreckage, military remains, and dumped materials can all complicate the seabed. Human activity leaves marks underwater just as it does on land, though usually with fewer signposts and far less convenient parking. Yet the reported circular form did not immediately fit the most familiar expectations for a shipwreck. A ship, especially a wooden or metal wreck, may have a recognizable long shape, debris field, keel line, or scattered remains. This object seemed different in the early imagery. It did not obviously look like a vessel lying on its side or a collapsed hull. That difference helped keep the question open. Explorers are often trained by experience to notice when something does not match the usual categories. A good searcher does not need to declare it supernatural. They simply say, "This is not what I expected," and sometimes that sentence is enough to start a long journey. There is also the matter of depth. Around 90 meters down, direct human exploration becomes more demanding. It is not impossible for trained divers, but it is far from casual. At that depth, dives require planning, equipment, decompression, and care. Visibility can be poor. Time on the bottom can be limited. Filming or sampling is not like strolling across a beach with a camera. Every minute costs effort. Every action is slowed by water, pressure, darkness, and safety requirements. This means that the first sonar impression can remain important for longer than it would on land. If someone saw a strange circular shape in a field, they could walk over and inspect it in an afternoon. If it is at the bottom of the Baltic, the question becomes a project. That gap between seeing and knowing is where mysteries grow. The sonar image said enough to raise interest, but not enough to settle the matter. The depth made immediate confirmation difficult. The shape was unusual enough to attract attention. The public comparison to a famous fictional spacecraft made it memorable. The team's later comments, and the media's appetite for the strange kept it alive. And underneath all of that, the object itself remained quiet. It did not become clearer just because people wanted it to. The seafloor has no obligation to provide better lighting. One careful way to think about the discovery is to separate the facts from the interpretations. A sonar image was taken during an Ocean X search in 2011. It showed an indistinct feature on the seafloor in the Gulf of Bothnia. The feature appeared unusual enough that the team took interest and later revisited the site. Claims were made about its size, shape, and nearby markings. Public speculation grew quickly, especially around artificial or extraterrestrial possibilities. Scientists and experts who later commented generally lean toward natural explanations, including glacial or geological processes. That is the sturdy frame of the story. Around that frame, many decorations were hung. Some were reasonable, some were imaginative, some were attached with far too much tape, but it would be unfair to pretend the first moment of discovery was not compelling. It was. A strange sonar image in deep northern water is compelling. The idea of an unexplained object resting on the seafloor is compelling. A feature that seems round, large, and set apart from its surroundings is compelling. Scientific caution does not require us to be bored. In fact, good caution often makes a mystery more interesting because it keeps us close to what can be known. It says, do not run so fast that you leave the evidence behind. Stay with the scan, stay with the setting, stay with the limits of the equipment, stay with the possibility that the Earth can make shapes that surprise us. The word anomaly simply means something that does not fit expectations. It does not mean alien. It does not mean impossible. It does not mean fake. It means unusual, or at least unusual from the point of view of the observer and the available information. That is a useful word here. The Baltic Sea anomaly was an anomaly because it looked strange on sonar and because it resisted immediate classification. It was not proof of a hidden civilization. It was not proof that scientists had no explanation for anything in the sea. It was a question mark drawn in echoes, and question marks are powerful. They are small shapes with large effects. They make people search, argue, test, return, doubt, and imagine. A question mark can launch an expedition, or keep someone awake reading articles when they promised themselves they would put the phone down 10 minutes ago. This one reached far beyond the boat that first recorded it. Soon, people who had never been near the Gulf of Bothnia were looking at the sonar image and deciding what they thought it must be. Some saw a crashed craft, some saw a bunker, some saw a natural formation, some saw a marketing opportunity, some saw nothing much at all, and probably slept better than everyone else. The interesting part is how quickly uncertainty became a story. In the early stage, the most honest statement would have been simple. A Swedish exploration team scanning the seabed found an unusual sonar return. They did not yet know what it was. That is a good sentence. It is accurate, calm, and useful. But it is not the kind of sentence that runs very far by itself. Add a circular shape, a possible trail, a deep location, and a comparison to a famous science fiction spacecraft, and suddenly the story has shoes. It can travel across websites, newspapers, forums, and television segments. By the time many people first heard about it, the careful sentence had changed clothes. It was no longer merely an unusual sonar return. It had become the mysterious Baltic Sea object that scientists could not explain. There is some truth hidden inside that dramatic version, but it needs handling carefully. Scientists could not fully explain the object from the public sonar images alone, because the images were limited. But that is different from saying science had no possible explanation. Geological and glacial explanations were available from the start, and they became stronger when experts considered the region's history. The northern Baltic seafloor has been shaped by ice, sediment, rock movement, and changing water conditions. A natural origin is not a weak fallback. It is exactly the sort of explanation one should expect in that environment. But because the object looked odd, and because the public data did not close the case neatly, the mystery stayed open in popular culture. For the OceanX team, the discovery was also practical. A strange feature could mean future expeditions, attention, funding, interviews and opportunities. That does not mean the discovery was invented. It means that, once found, it existed in a world where stories and resources matter. Underwater exploration is expensive. Boats cost money, equipment cost money, divers, fuel, repairs, permits and time all cost money. Public interest can help make return trips possible. But public interest also prefers drama over caution. That creates a difficult balance. If explorers speak too cautiously, nobody listens. If they speak too dramatically, experts raise eyebrows, and the mystery becomes tangled with promotion. The Baltic Sea anomaly lived right in that uncomfortable middle space. It is worth pausing on the ordinary human side of the moment. Picture the crew looking at the screen. The water outside is not doing anything theatrical. The sea does not glow. No great bubble rises from below. There is just a vessel moving over dark water and equipment returning data from a hidden landscape. Someone notices the shape. Someone points. Someone compares it to things they know. There may be excitement, confusion, jokes, doubt, and a sudden increase in people leaning toward the monitor. That is how many discoveries begin, not as certainty, but as attention. A shift in posture, a second look, a quiet decision not to ignore what has appeared. That decision matters because most of the seafloor is never examined closely. Even in mapped areas, many features remain unnamed and unvisited. The ocean is filled with shapes that would seem strange if placed in front of us on land. Underwater, they are allowed to remain anonymous. The Baltic Sea anomaly became famous not only because it looked unusual, but because someone noticed it, saved the data, shared it, returned to it, and allowed the question to leave the boat. There may be countless other odd shapes resting in darkness, never becoming mysteries because no one has framed them on a screen and said, "Look at this." So, the day the sonar found something strange was not a clean discovery of an object in the way a person finds a coin on a pavement. It was the discovery of an image, and then the discovery of a question inside that image. The object, if we call it an object, was already there. It may have been there for centuries, thousands of years, or much longer depending on what it is. The sonar did not create it. The sonar translated it into a form humans could argue about. Sound went down. Echoes came back. A shape appeared. Then imagination, science, skepticism and speculation all arrived. Not in a neat line, but in a crowd. And above that crowd, one practical need remained. The team would have to go back. A single sonar image, however intriguing, could not carry the whole story. They needed more scans, more angles, closer inspection, perhaps divers, perhaps samples, perhaps video. The first image had done what first images often do. It had opened the door just enough to let in cold air. Now someone had to decide whether to step through, knowing that below the surface there would be darkness, pressure, poor visibility, and a feature that might become more mysterious up close, or might turn out to be the most famous rock pile in northern Europe. That is the gentle trouble with the unknown. From a distance it can look almost anything like a machine, a ruin, a message, a mistake, a natural form wearing the costume of design. The closer you get, the more some possibilities fall away, but the more details you have to explain. The Baltic Sea anomaly had moved from seabed feature to public mystery because of one strange sonar return. What came next would depend on whether the later evidence could sharpen the picture, or whether the Baltic would keep its answer blurred in the dark water, where every edge looked important and every shadow seemed to have something more to say. What came back on the screen was not a photograph. That is worth holding in mind as we move closer to the famous image, because much of the story depends on this simple fact. Nobody, in that first moment, was looking at a clear underwater picture of an object sitting in bright light. There was no sharp camera view showing walls, metal plates, markings, doorways, windows, or anything as helpful as a small label saying, "Made in a mysterious ancient civilization, Please handle carefully. What they had was sonar data, echoes, reflections, a picture made from sound bouncing off the seafloor and returning to the equipment after touching whatever shapes lay below. And yet, even with all those limits, the image had a strange pull. It had the kind of shape that makes people lean in. A rough seabed might be interesting to a geologist, but to most of us it is just texture. Ridges, slopes, patches of sediment, scattered stones, all of it can blur into a grey underwater landscape. But this was different enough to stop the eye. There, in the sonar image, was a broad rounded form that seemed to stand apart from the surrounding bottom. It looked circular, or at least circular enough that the word quickly attached itself to the story and refused to leave. It seemed wide, heavy, and oddly placed. Not a tiny dot, not a small rock, not some little bit of lost equipment that could be dismissed as the sea's version of pocket change. This thing appeared large, about 60 metres across according to the reports that spread afterward, which is large enough to make a person pause before calling it nothing. A shape that size under the sea does something unusual to the imagination. If it were sitting in a field, perhaps people would gather round it, walk across it, poke it, take samples, argue for a few days, and then slowly calm down. But because it rested far below the surface, it had distance working in its favour. Distance is very good at making mystery larger. Add cold water, poor visibility, and a difficult location, and suddenly the shape becomes more than a shape. It becomes a question that cannot be answered quickly. And unanswered questions, as we know, are where the mind begins rearranging the furniture. The public images seem to show a central mass with edges that look too neat for comfort. Some viewers thought they saw straight lines. Others thought they saw a raised outer rim. Some pointed to what appeared to be grooves, steps, or pathways across the surface. There were claims of a central depression, as if part of the object dipped inward. Depending on which version of the image someone saw, and how much outlining had been added by media graphics, the feature could look like a round platform, a broken structure, a crashed disc, a carved base, or, most famously, something a little like the Millennium Falcon from Star Wars. Once that comparison entered public discussion, it became difficult to remove. The mind likes a familiar shape. Give it a grey circle in the deep and then whisper spaceship, and suddenly the circle seems to acquire engines, corridors, and perhaps a slightly irritated pilot wondering where he parked. But this is where we need to be careful. A sonar image is not the same as the thing itself. It is a representation of how sound interacted with the seafloor. The lighter and darker areas do not simply mean visible surfaces as they would in a normal photograph. They may represent stronger or weaker echoes, changes in slope, acoustic shadow, or differences in the material on the bottom. A raised area can cast a shadow in sonar, and that shadow can exaggerate the sense of height. A rough surface can create sharp-looking returns. A soft sediment patch may look smooth. An edge may be real, or it may be the effect of angle, processing, or the way the sonar passed over the feature. It is a little like trying to identify furniture in a dark room by listening to how your voice echoes back, except the room is 90 meters underwater, and the furniture may actually be a pile of rocks minding its own business. Still, there were details that made the image hard to ignore. One of the most discussed was the apparent trail, or track nearby. In some descriptions, it looked as though the circular feature sat at the end of a long disturbance on the seabed. This was immediately dramatic. A round object with a trail is much more exciting than a round object without one. The trail suggests movement. Movement suggests an event. An event suggests a story. Perhaps it slid. Perhaps it crashed. Perhaps it was dragged. Perhaps something landed there and carved the bottom as it came to rest. The human brain, trying to be helpful and also perhaps a little overenthusiastic, begins building a sequence. First there was motion, then there was impact, then there was silence, then was impact, then there was silence. Then, years later, a sonar scan found the remains. That story is neat. Too neat, perhaps. The seafloor can produce long marks in many ways, especially in a region shaped by glaciers and later underwater processes. Ice can scrape across rock, stones can be moved and deposited, sediment can form ridges and mounds, currents can sort material over time, fishing activity can leave marks as well. A line near an object does not automatically mean the object made the line. On land, we understand this more easily. If you saw a round boulder near a long shallow trench, you might wonder if it rolled there, but you might also consider erosion, drainage, tyre tracks, digging, or an older natural feature. Underwater, because the setting is less familiar, our everyday caution sometimes goes out for a walk and forgets its coat. The circular appearance also deserves patience. Nature makes circles and near circles more often than people expect. There are round stones, circular depressions, glacial features, erosion patterns, and mineral formations that can look almost designed. There are also cases where an object only appears circular from one viewing angle. A mound may be irregular in 3 dimensions, but from one sonar pass with certain shadows and contrast, it may look much neater than it really is. A person viewing a single image may think they are seeing the full truth of the form, when they are really seeing one acoustic portrait taken from one perspective, with its own distortions and gaps. It is like judging a whole house from one blurry photograph taken through a rainy window. You may get the general idea, but it is best not to start naming the curtains. This is part of why scientists and sonar experts were cautious. The image was interesting, but it was also indistinct. Some experts criticised the quality of the sonar data and warned that the image could not support firm conclusions about what the feature actually was. That may sound disappointing at first. It is much more fun to hear that an image is clear enough to change history. But in real investigation, disappointment is often useful. It keeps us from turning a maybe into a definitely. It reminds us that the sea does not owe us a clean answer just because a picture looks good on a headline. The shape did seem unusual to many viewers. That much is fair. A completely ordinary sonar return probably would not have travelled around the world. It was the combination of things that made the image memorable. The rounded outline, the reported size, the nearby line or track, the dark Baltic setting, the limited visibility, the fact that the team had been searching for wrecks, and the later suggestion that divers found the site odd when they returned. Each piece alone might not have caused much excitement. Together they became a story with a strong hook. A circle in the deep is simple enough to remember. It can be drawn in the mind. It can be compared to many things. It can carry speculation easily, and speculation arrived quickly. People looked at the sonar image and saw different things depending on what they already expected to find. Those interested in UFO stories saw a sunken craft. Those interested in ancient civilizations saw a possible structure. Those with a military imagination wondered about wartime remains, secret installations or discarded equipment. Others saw geology, ice and rock. The same image became a kind of mirror. It reflected not only the seafloor but the viewer's preferred kind of mystery. This is not unusual. Ambiguous images often work this way. They invite interpretation because they do not provide enough information to stop it. A good example is the supposed straight edges. Straight lines feel artificial to us because human-made things often use them. Buildings have straight walls, machines have straight panels, roads have straight sides. So when people see something straight looking underwater, they may think of construction. But straightness by itself is not proof of design. Rocks fracture along plains. Layers of sediment can create edges. Ice can scrape or cut. Sonar processing can sharpen contrast in ways that make a boundary appear cleaner than it is. A line may look straight at low resolution because smaller irregularities are not visible. Seen up close, the same edge might be jagged, broken, and entirely natural, like a biscuit that looked perfectly round from across the room, until you reached for it and discovered someone had already taken a very suspicious bite. The same caution applies to claims of steps or stair-like features. Underwater rock formations can have ledges. Sedimentary layers can break into tiered surfaces. Glacial deposits can leave uneven levels. If a sonar image or later underwater footage appears to show layered shapes, it does not automatically mean stairs. Stairs require more than repeated levels. They require intent, function, and usually a context that supports construction. A set of rock ledges can resemble steps without ever having carried a foot. Nature has no problem producing features that seem familiar. It does not check with us first to make sure it is not being misleading. There was also discussion of an opening or central depression. That too caught attention because holes and depressions suggest purpose. A central hollow can make a feature look like a platform, a socket, a chamber, or part of a machine. But depressions form naturally in many ways. Softer material can erode, sediment can settle, rocks can break away, a mound can have an uneven top. A sonar shadow can make a low area seem more dramatic than it is. The tricky thing is that, in a mystery, every irregularity becomes a clue. A bump becomes a dome. A crack becomes a doorway. A hollow becomes an entrance. Before long, a seafloor formation has a floor plan, and nobody has even found the front door. The Baltic Sea anomaly became especially vulnerable to this, because the early images were not detailed enough to settle what the surface was actually like. If the data had been extremely sharp, many theories might have died quickly. If the data had been extremely poor, perhaps no one would have cared. Instead, it sat in the middle, clear enough to suggest, unclear enough to permit. That is the dangerous sweet spot for a mystery. The mind fills in missing information, and once it has filled in the gaps, it can become attached to its own work. Nobody likes being told that the castle they built in the fog may just be fog with a few stones in it. Another reason the image seems so strange is that most of us do not spend much time looking at raw or semi-processed sonar data. We're used to photographs, maps, and clean diagrams. We expect images to behave like pictures. Sonar does not always behave that way. Shadows can seem like holes. Strong returns can seem like solid walls. Weak returns can look like empty space. The scale can be difficult to feel. The angle of the scan affects the shape. Features can stretch or compress. Without training, and sometimes even with training, interpretation requires caution. It is very easy to treat the image as if it were a clear overhead view when it may be closer to a textured echo map. The media presentation added another layer. Once images are cropped, sharpened, outlined, brightened, labelled, or placed beside dramatic comparisons, the viewer is no longer seeing just the original data. They are seeing the data plus suggestion. A drawn outline can guide the eye. A headline can guide the mind. A comparison to a spaceship can guide the imagination straight out of the harbour and into deep space before anyone has checked the anchor. This does not mean every media report was dishonest. It means presentation matters. The way a mystery is framed can become part of the mystery itself. And then there is the problem of scale. 60 metres across sounds large, but underwater geology works at scales much larger than human objects. A glacial deposit can be huge. A rock outcrop can be broad. A mound or ridge on the seafloor can easily be bigger than a building. We tend to compare unknown things to familiar human-made objects, because those are easier to imagine. A 60-metre circle becomes an aircraft, a platform, a base. But the Earth has been shaping surfaces for billions of years without asking whether the result fits our categories. A natural formation does not become less natural because it is the size of something we might build. The reported location, in the Gulf of Bothnia, also matters because the northern Baltic was strongly affected by Ice Age processes. Glaciers once moved across the region, carrying stones, grinding bedrock, and leaving behind deposits as they retreated. These processes can create mounds, ridges, grooves, and scattered rock features that look odd on modern seafloor maps. Imagine a giant, slow-moving sheet of ice acting like a rough hand across the landscape, dragging material, pressing it down, scraping, smoothing, breaking and rearranging. Then imagine the ice melting, water filling the basin, sediments settling, and thousands of years passing in darkness. What remains may not look tidy, but it can look structured. It can look like something happened there, because something did happen there. Not a crash, perhaps, but the long physical work of ice and stone. That is one of the calmer ways to look at the anomaly. It may be less like an object placed on the seafloor, and more like a feature of the seafloor itself. The word object subtly changes the way we think. An object sounds separate, it sounds placed. It suggests that if we could just get a large enough crane, we might lift it away and reveal its underside. A formation, by contrast, belongs to the landscape. It may be part of the bedrock, a deposit, or a mound connected to wider geological patterns. The early popular story favoured object, because objects are more exciting. Science often asks whether formation is the better word, which is less glamorous but usually sleeps better at night. Still, it is understandable that people wanted the image to show something artificial. The ocean is one of the few places on Earth where a large mystery can still hide in plain sight, or rather, in no sight at all. We have mapped cities, roads, farms, deserts, and mountains with remarkable detail, but underwater landscapes remain less familiar to most of us. A strange shape at the bottom of the sea feels like an invitation. It gives the imagination permission to visit lost worlds. We picture ruins covered in silt, machines resting after a forgotten accident, structures from people whose names never reached history. It is not foolish to feel that pull, it is human. The trick is not to let the pull become proof. The images seem to show a circle, but they did not show who or what made it. They seem to show edges, but not whether those edges were natural fractures or constructed boundaries. They seem to show a trail, but not whether the circle caused it. They seem to show a surface with details, but not whether those details were steps, cracks, ledges, shadows, or processing effects. The more carefully we describe the image, the more the mystery changes shape. It becomes less about a definite object and more about uncertainty itself. What can we responsibly conclude from limited data? How much of the image belongs to the seafloor, and how much belongs to the way sound, equipment, and expectation translated it? This is not a way of making the anomaly boring. In fact, it may make it more interesting. A confirmed artificial structure would be astonishing, of course, but an ambiguous image that reveals the limits of perception, technology, and public storytelling has its own value. It shows us how knowledge is built. Slowly. With checks. With return visits. With better instruments. With samples. With disagreement. With people saying, wait, before we call it a spacecraft, let us first ask whether the sonar was calibrated correctly. Not the most dramatic sentence, perhaps, but a very useful one to have around. There is a quiet comedy in how the anomaly became famous through an image that experts later warned was not strong enough to carry the claims being placed on it. It is a bit like inviting a very small table to hold an entire wedding cake. The table may be perfectly fine for tea, but at some point something is going to wobble. The sonar image was enough to begin curiosity. It was not enough to support every theory that climbed onto it afterward. And yet, because the image looked just strange enough, people kept returning to it, tracing its outline with their eyes, trying to decide whether they were seeing a natural seabed formation, or the edge of a story much bigger than geology. When divers and later investigators entered the conversation, the image did not disappear. It remained the central symbol. Even if new scans, samples, or expert opinions suggested natural explanations, the original sonar picture kept circulating. That often happens with mysteries. The first image becomes iconic. It freezes the question at its most exciting moment, before explanations have had time to dull the edges. People remember the first strange shape more vividly than they remember the later caution. The mystery stays young in the public mind, even as the investigation becomes older and more complicated. So, what did the images seem to show? They seemed to show a large rounded feature on the Baltic seabed, with surrounding marks and surface details that many people interpreted as unusual. They seemed to show enough symmetry to raise eyebrows. They seemed to show enough ambiguity to allow almost any theory to wander in and make itself comfortable. But they did not clearly show an artifact. They did not clearly show a craft. They did not clearly show a ruin. They showed a puzzle made of sound, shadow and seafloor texture. And because the puzzle lay deep under cold water, it could not be solved by simply looking harder at the same picture. To move beyond the image, someone had to go down. Not into a clear tropical lagoon, not into warm, shallow water, but into the dim Baltic, where the object or formation rested in low visibility and silence. The sonar had done its part. It had pointed. It had said, "There is something here that looks different." Now the question was whether human eyes, cameras, samples and close inspection could turn that strange circle into something clearer, or whether the closer view would only reveal another layer of rock, silt and uncertainty, waiting patiently beneath the first. To move beyond the image, someone had to go down. That sounds simple when said from a dry room with a warm drink nearby, but in the Baltic Sea, simple things have a habit of putting on heavy boots. The sonar had pointed to something unusual on the seafloor. It had shown a rounded feature, a possible trail, and enough strange geometry to make the story spread far beyond the people who first saw it on a screen. But sonar could only take the investigation so far. At some point, if the team wanted more than echoes, divers had to leave the boat, enter the cold water, and try to see what the machine had suggested was there. This was where the mystery became less like a headline and more like a difficult piece of work. On paper, send divers to inspect it sounds almost too obvious. There is a strange object underwater. Put people in diving suits, let them look at it, bring back answers, maybe a few photographs, maybe a sample, maybe, if the sea is feeling generous, a clear explanation and a tidy ending. But the sea is not a helpful office assistant. It does not arrange its evidence neatly in folders. It does not improve visibility because people online are impatient. It does not say, "Yes, of course, here is the object from the best angle, and I have dusted it for you." The reported depth of the anomaly was around 90 meters, deep enough to make diving serious. Not impossible, but serious. A person does not simply drop down there for a casual look and return with a cheerful wave and a bag of souvenirs. At that depth, every part of the dive needs planning. The pressure is much greater than at the surface. Breathing gas must be managed carefully. Time on the bottom is limited. Returning to the surface must be done in stages to avoid decompression sickness, which is what happens when dissolved gases form bubbles in the body during a fast ascent. It is not the sort of thing one wants to treat casually. The sea is quite firm about physics, even when everyone is excited about a possible underwater mystery. The Baltic also adds its own particular difficulties. It is not famous for crystal clear visibility. Its water can be murky, greenish, dark, and full of suspended particles. At depth, sunlight fades quickly. The bottom can be covered with silt that rises into clouds if disturbed. A diver's own movement can make the view worse. One careless fin kick near loose sediment and the scene can turn from investigating a historic mystery to staring into soup. Not even a glamorous soup. More like the kind that has been sitting at the back of the fridge with an uncertain future. So when divers approached the site, the public expectation and the underwater reality were very different things. Above the surface, people wanted confirmation. Was it a craft? Was it a structure? Was it natural? Was there a door? Were there stairs? Were there markings? Below the surface, the first challenge was more basic. Where exactly is the feature? How close are we? What can we see? Is that rock, shadow, silt, or part of the object? Is the camera working? Is the light reaching anything useful? Are we stirring up the bottom? How much time do we have before we must begin the ascent? The idea of seeing underwater needs to be treated carefully. Human eyes are not at their best down there. Even with lights, cameras and trained divers, the view can be narrow and confusing. On land, we can step back to understand the shape of something large. If you stand too close to a building, you see bricks, corners, pipes, and windows. Step back and you understand the whole structure. Underwater, stepping back is not always available in the same way. Visibility may only allow a short range. A large formation can be impossible to take in at once. A diver may see a surface, a ridge, a crack, or a raised section, but not the full 60-metre outline that looks so dramatic on sonar. It is like trying to identify a dinner plate by looking at 1 square centimetre of it through fog while wearing gloves, breathing through equipment, and knowing your parking meter is running. This is one reason the later dives did not instantly solve the mystery in the public mind. People expected a close view to be better than sonar, and in some ways it was. Divers could touch the surface, inspect textures, take samples, and observe details that sonar could not show. But in other ways, the close view could be more confusing. Sonar gave the broad shape. Diving gave fragments. If the water was dark and visibility poor, the fragments did not easily assemble into a complete picture. A diver might report that the surface felt hard, rocky, uneven, or strange. But those words do not tell the world whether the entire feature is a natural outcrop or a constructed platform. Close contact does not always mean full understanding. Anyone who has ever tried to assemble flat-pack furniture from unclear instructions knows this principle well, although usually with fewer air tanks. The OceanX team's reports about the dives added to the mystery. They described unusual features, hard surfaces, and places that did not seem to match a simple, soft sediment bottom. They also made claims about electronic equipment behaving strangely near the anomaly, including reports that some cameras, satellite phones, or other devices stopped working when the boat was positioned above the site and worked again when moved away. These claims became one of the most repeated parts of the story. They sounded like the kind of detail that belongs in a science fiction scene. Equipment failing near a mysterious circular object on the seafloor is almost too convenient for the imagination. It walks into the room wearing a dramatic coat and says, "Please, do speculate." But claims about equipment failures need caution. Equipment fails at sea all the time. Salt water, pressure, cold, batteries, cables, connectors, moisture, poor signal, user error, and plain bad luck are all hard-working members of the technical problem family. Satellite phones can lose signal for reasons that have nothing to do with mysterious energy fields. Cameras can fail underwater because underwater cameras enjoy reminding humans who is really in charge. Lights can flicker, batteries can drain, housings can leak, navigation can be difficult. A strange equipment problem near a strange site is interesting, but by itself, it is not proof of anything hidden inside the object. It is a clue only if it can be measured, repeated, and separated from ordinary failure. Otherwise, it remains a story, and stories are much easier to carry than data. Still, it is easy to understand why that detail stayed alive. A natural rock formation does not usually make cameras fail in people's minds. A crashed machine might. A buried installation might. A powerful unknown object might. So the equipment stories became attached to the anomaly like barnacles to a hull. Even when experts leaned toward geology, the public memory kept returning to that idea. Why did the equipment stop? Why did it work again away from the site? Was there some kind of interference? Was it coincidence? Was it exaggerated? Was it misunderstood? These are reasonable questions, but they cannot be answered properly without careful records. What exact devices failed? At what distance? Under what conditions? Were the failures repeated on multiple trips? Were control tests done elsewhere? Were independent teams able to confirm it? Without that, the claim stays interesting, but it does not become strong evidence. The divers also had the problem of scale. Imagine hovering beside a formation that may be around 60 meters wide. From the sonar image, it can look like one object. From a diver's position, it may feel like a landscape. A raised section here, a crack there, a flat patch under one glove, a slope fading into darkness. If the feature is natural, it may still contain surfaces that seem unusual. If it is rock, it may have ledges, fractures, and sediment pockets. If it is a glacial deposit, it may include stones of different sizes and materials. If it is a bedrock outcrop, it may have planes and breaks that look almost cut. A diver encountering these details in low light could easily feel that the site is strange. Strange does not automatically mean artificial, but it does mean the diver's reaction may be sincere. This is important. We do not have to assume that everyone involved was pretending or foolish. The underwater environment really can be confusing. The feature really did attract attention. The conditions really did make direct inspection difficult. The divers may have seen and felt things that seemed unusual to them. At the same time, a sincere impression is not the same as a confirmed explanation. A person can honestly say, "This does not look normal to me," while a geologist later says, "This is within the range of natural formation." Both statements can exist together. One describes experience, the other asks for classification. When samples were reportedly taken from the area, they became part of the next stage of the debate. Pieces of stone or material from the site could be tested more directly than a sonar image. This is where the mystery began to lean more strongly toward geology in the eyes of many experts. Some analyses identified ordinary rock types consistent with natural processes in the region, including materials that could have been transported or left behind by glacial activity. That did not satisfy everyone, partly because the sample location matters. If a diver picks up stones near a formation, are those stones part of the formation itself, resting on top of it, or simply lying nearby? Underwater sampling is not automatically simple. A rock from a site is not always a rock from the structure people are imagining. It may be a loose stone, it may be a surface fragment, it may be representative, or it may not. The sea, once again, refuses to behave like a clean laboratory bench. The public wanted a single decisive result. The sample is artificial. The sample is natural. Mystery solved. Please collect your coats on the way out, but real fieldwork often produces messier answers. A sample may show common rock, but the feature may still require mapping to understand its shape. A sonar image may look artificial, but a dive may reveal natural textures. Divers may report odd experiences, but instruments may not confirm a physical anomaly. Each piece of evidence has limits. The challenge is to combine them without forcing them into the story we prefer. The darkness itself played a major role. Darkness is not just a lack of light in a mystery. It becomes part of how the mystery is perceived. In clear daylight, many things lose their drama. A pile of stones becomes a pile of stones. A shadow becomes a fence. A strange sound becomes the refrigerator. At 90 meters in the Baltic, the world does not lose its drama so easily. Lights reach only so far. Cameras struggle. Surfaces appear in patches. A diver sees what the beam touches, and beyond that, the shape continues into black water. This makes the mind work harder. It fills in the unseen sections. It connects partial views. It may add order where there is only a regular rock. It may also misorder if it is looking at the wrong part. Darkness does not simply hide things. It changes how we think about them. Silt can do the same. A seafloor covered with loose sediment can soften edges, hide cracks, bury objects, and create smooth-looking surfaces over rough material. If sediment is disturbed, it can hang in the water and reduce visibility further. For divers trying to film or inspect a large area, that can be frustrating. Move too close and you stir the bottom. Stay too far away and you cannot see detail. Use strong lights and particles reflect back like underwater dust, filling the camera view with tiny bright specks. It is the ocean's way of saying, you wanted evidence, so here is a snow globe. Depth affects colour as well. Red and orange wavelengths disappear first underwater, leaving the world blue, green and grey, unless artificial light brings colours back. Rock surfaces can look different under dive lights than they would in air. Textures can seem harsher or smoother depending on angle. A crack may cast a long shadow. A small ledge may look like a step. A flat patch may seem like a floor. A rounded stone may seem like part of a pattern. This is not because divers are careless. It is because underwater perception is difficult, and the brain is always trying to help by making quick sense of incomplete information. The need for cameras made things even more complicated. The public wanted video. Of course it did. Video feels convincing. But underwater video in low visibility can be disappointing. The camera may capture close surfaces but not the overall shape. The footage may be shaky. Lights may glare off particles. Scale may be hard to judge. A rock face filmed close up can look like a wall. A ledge can look enormous if there is no reference point. Without careful mapping, measurements and context, video can create as many questions as it answers. People watching later may see what they expect, just as they did with the sonar image. This is why underwater archaeology and marine geology rely on more than a diver's glance. Good investigation often needs repeated surveys, high-resolution sonar from multiple angles, remotely operated vehicles, precise positioning, photogrammetry, sampling plans, and independent review. Photogrammetry, for example, can use many overlapping photographs to build a three-dimensional model. But to do it well underwater, the team needs clear enough water, steady imaging, scale markers, and careful coverage. Multi-beam sonar can map the bottom in more detail, but equipment quality, survey design, and interpretation all matter. None of this is as quick as posting one dramatic image and letting the comments section solve the universe by breakfast. For Ocean X, returning to the Anomaly was also a test of expectation. Once a site has become famous, every observation is placed under pressure. If divers say the surface is hard, some listeners hear metal. If they say there are lines, some hear construction. If they say equipment failed, some hear energy field. If they say the site is strange, some hear impossible. Words become slippery. A careful phrase can be stretched by retelling. Unusual formation becomes unexplainable object. Equipment problems occurred becomes the anomaly disabled all electronics. Samples included rock becomes either proof it is natural or only the outer covering was sampled, depending on what the listener wants. The mystery does not only live underwater, it also lives in the way sentences travel. The diver's situation was therefore unenviable. They were expected to bring back certainty from a place built for uncertainty. They were operating in difficult conditions with limited time, limited visibility, and a public already hungry for a dramatic answer. Even if the feature was natural, proving that to public satisfaction would require more than saying, "We saw rock." People could respond yes, but what is under the rock? What about the shape? What about the trail? What about the equipment? What about the central depression? A mystery can always move one step away from the evidence. That is one reason it survives. On the other hand, if the feature were artificial, the same diving difficulties would still apply. A constructed object sitting for a long time underwater could be covered in sediment, colonized by marine growth, broken, eroded, or partly buried. It might not look clean or obvious, so the fact that it was hard to interpret did not automatically prove nature either. This is where patient method matters. The question is not whether the first dive felt strange. The question is what the combined evidence supports best. So far, the stronger expert view has remained that the anomaly is most likely natural, especially given the region's glacial history and the ordinary nature of reported rock samples. But the diving phase explains why the public did not feel the matter was closed. The close view did not deliver a single satisfying image that everyone could understand. There is also a psychological difference between sonar mystery and diving mystery. Sonar mystery is distant and geometric. It gives a shape. Diving mystery is physical and immediate. It gives cold, darkness, texture, and the feeling of being near something that cannot be fully seen. For a diver, the experience may be memorable even if the object is only rock. To descend through dark water toward a famous unexplained feature, to reach the bottom, to shine a light over hard surfaces, to know the boat is far above and the world is reduced to breathing, instruments, and the beam of a lamp that would leave an impression. Human beings are not machines. We bring nerves, imagination, and context with us. A strange place feels stranger when you already know it has been called a mystery. The Baltic itself adds to that feeling. It is not an empty tank. It has history. Ships have sunk there. Wars have moved across it. Ice has shaped it. Fishing gear has dragged over parts of it. Sediments have settled through thousands of quiet years. A diver on the bottom is not just looking at one feature. They are moving through a landscape made by many overlapping processes, some human, most natural, all partially hidden. The anomaly sits within that setting. It is not a prop placed on a stage. It belongs to a seafloor with its own complicated past. What the dives really showed, in a broader sense, was the gap between public mystery and field investigation. The public version asks, what is it? The field version asks many smaller questions first. What is the bottom composition? What is the exact shape? Is the feature attached to bedrock? Is it a deposit? Are the apparent lines continuous? What does the surrounding bathymetry show? Are there similar formations nearby? Are the samples representative? Can the equipment failures be reproduced? What does higher quality sonar show? Are the claims based on measurements or impressions? It is less dramatic but much more useful. Science often wins not by having one grand answer, but by asking enough small questions that the grand answer no longer has anywhere vague to hide. And still, there is something compelling about those dives. They turned the anomaly from a shape on a screen into a place people had physically visited. That matters for the story. A sonar image can feel unreal, but divers descending to the site make it concrete. There was water, there was a bottom, there were surfaces to touch, there were samples to collect. The object, formation, mound, or rocky feature was not imaginary. Whatever the final explanation, there is something down there. That alone separates the Baltic Sea anomaly from many mysteries that dissolve when checked. This one does not dissolve completely. It becomes more ordinary in some ways and more complicated in others. The trouble is that ordinary and complicated do not make a neat pair. A natural formation can still be hard to map. A glacial deposit can still look unusual. A rock outcrop can still produce a striking sonar image. A dive can still feel eerie. Equipment can still fail for boring reasons at exactly the wrong moment. And once all of these things happen together, the story keeps breathing. It does not need proof of aliens to survive. It only needs enough uncertainty to keep the door slightly open. That is why the diving phase is one of the most important parts of the Baltic Sea anomaly story. It reminds us that going closer does not always mean seeing clearly. The closer view may reveal texture, but lose the larger outline. It may answer one question while creating three more. It may replace the clean mystery of a circle with the messier reality of rock, sediment, darkness, claims, samples, and human interpretation. The first sonar image made the object look simple. The dives made it complicated. Down there, in the limited reach of dive lights, the famous circle was no longer a neat shape on a screen. It was a cold, hard surface in dark water. It was patches, edges, shadows, and sediment. It was a place where every observation needed context and every claim needed care. The divers could bring back impressions, footage, and samples, but the sea kept control of the full picture. It allowed glimpses, not certainty. It gave enough to continue the investigation, not enough to quiet everyone. And while people above the surface debated what the divers had seen, the next question began to form naturally. if close inspection did not clearly reveal a machine, a ruin, or a craft, then what else could make such a shape? What kind of natural process could leave a large rounded feature on the Baltic seabed? To answer that, the story had to move away from the excitement of the dive and into the slower world of geology, where ice, stone, pressure, and time can build forms that look strange enough to fool even a very confident imagination. Once the divers returned with their descriptions, their samples, their low visibility footage, and their stories of strange equipment behaviour, the Baltic Sea Anomaly had everything it needed to become more than a sonar image. It had become a stage. The setting was good: cold northern sea, a deep location between Sweden and Finland, a circular shape on the bottom, divers reporting that the place felt unusual, a possible trail beside it, a few frustrating images that showed enough to interest people but not enough to settle anything. That combination is very powerful. It is the mystery equivalent of leaving a cupboard door slightly open in a quiet house. You may know there is probably nothing dramatic inside, but the mind still wants to check, and once the mind starts checking, it brings friends. The first and loudest theory was, of course, the UFO theory. It arrived almost immediately, wearing shiny boots and carrying its own dramatic music. A round object on the seafloor, roughly 60 meters across, with what looked to some people like a trail or drag mark leading to it, was simply too tempting. For anyone already interested in unidentified flying objects, the basic outline was ready-made. Perhaps, they said, this was not a natural rock formation at all. Perhaps it was a craft that had entered Earth's atmosphere long ago, lost control, struck the Baltic and slid across the bottom before coming to rest. The circular shape became a disc. The trail became a crash path. The strange equipment reports became evidence of residual energy. The cold water became a hiding place. It was a complete story, and complete stories are very attractive when the facts are incomplete. There is a reason this theory spread so easily. People do not need much training to understand the idea of a crash. We see crash marks on roads. We understand movement, impact, damage, and rest. If something round sits near a long mark, the mind can imagine it sliding. It is simple, it is visual, it does not require complicated geology. It does not ask us to learn how glaciers shape the Baltic basin, which, while very important, does not usually make people spill their tea in excitement. A crashed craft, on the other hand, is instantly dramatic. It also offers the possibility that the object contains something hidden, something technological, something that would change history if someone could only get close enough to open it. That is very difficult for imagination to resist. Even imagination, after all, enjoys a locked door. The comparison to the Millennium Falcon made the situation worse, or better, depending on whether you're a scientist or a headline writer. Once people saw that resemblance, they could not easily unsee it. The sonar image, with its rounded shape and uneven details, was placed beside the famous fictional spacecraft in articles and online discussions. And suddenly, the Baltic Sea had acquired a connection to one of the most recognisable spaceships in popular culture. It did not matter that the comparison was loose. It did not matter that a side-scan sonar image is not a photograph. It did not matter that the real seafloor may have looked much less tidy than the public image suggested. The resemblance gave the story a handle. People could remember it. People could repeat it. The underwater object that looks like the Millennium Falcon is a sentence built to travel. But the UFO theory also had problems from the start. A shape that looks a little like a spacecraft is not evidence of a spacecraft. A round object is not automatically a flying saucer. A trail is not automatically a crash path. Equipment problems are not automatically electromagnetic interference from unknown technology. And if a large craft had crashed into the Baltic Sea, we might expect other evidence. Not necessarily easy evidence, because the sea hides things well, but still something more than an unclear sonar return and difficult dive reports. We might expect unusual materials, clear metal structures, manufactured components, radiation, magnetic readings, repeated instrument measurements, or samples that do not match ordinary geology. The public story had atmosphere. What it lacked was the kind of hard evidence that makes a strange idea stand up without leaning on excitement. That did not stop the theory from spreading, because a theory does not always need strong legs if enough people are willing to carry it. It only needs to feel possible in the space where certainty is missing. The Baltic Sea anomaly gave UFO believers an excellent place to rest their curiosity. It was remote, hard to inspect, visually odd, and surrounded by enough unanswered details to keep the door open. And in mysteries like this, an open door is often treated as an invitation, even if there is a perfectly ordinary broom cupboard on the other side. Then came the ancient ruins theory. This one was quieter than the crashed UFO theory, but in some ways it was more flexible. Instead of looking upward to space, it looked backward into human history. Perhaps, some suggested, the anomaly was part of an ancient structure, a submerged ruin, or the remains of a lost settlement. The Baltic Sea region has changed over time. Sea levels, coastlines and landforms have shifted since the last ice age. Areas that are underwater today were not always underwater. Humans have lived around the Baltic for thousands of years, so the idea that something ancient might lie beneath the water is not foolish in itself. Archaeologists do find submerged landscapes, old settlements, fish traps, and structures in coastal regions around the world. The sea has covered many human places. It is not unusual for the past to be wet. That is what made the ruins theory more interesting than the wildest versions of the UFO theory. It began with a real principle. Human history and changing coastlines do overlap. Ancient people did build things near water. Some of those things are now underwater. The Baltic has preserved remarkable wrecks and objects because of its cold, low-oxygen conditions. So when people looked at the anomaly and thought of a platform, a wall, or a constructed base, they were at least reaching towards something that happens in the real world. The trouble was that the evidence still did not clearly support it. A possible ancient structure needs more than a strange outline. It needs context, tool marks, arranged stones, artifacts, dating evidence, cultural material, or a pattern that makes sense as human construction. Without those, a rocky surface can easily be mistaken for ruins, especially when seen through sonar shadows and dark water. There is also the matter of scale and setting. A 60-metre circular feature would be a significant structure. If it were built by people in the ancient Baltic region, it would raise many follow-up questions. Who built it? When? For what purpose? Was it once on dry land? Was it part of a larger site? Are there associated artifacts nearby? Does the surrounding seabed show signs of an ancient shoreline, settlement, or construction activity? These questions are not meant to dismiss the idea. They are the questions that would have to be answered for the idea to become more than a possibility. Archaeology is not just looking at a shape and saying, that feels human. It is the slow work of placing evidence into a human pattern. A single odd formation without artifacts or context is difficult to call a ruin. Still, people like ruins. There is something gentler about this theory than the crashed craft idea. A lost human structure under the Baltic would not necessarily break physics or rewrite the cosmos. It would not require visitors from another star. It would simply suggest that human history in that place had left behind something larger, stranger or older than expected. That is appealing. It gives the anomaly a connection to hands, tools, fires, families, shorelines, and people who may have watched a very different Baltic horizon. It is an emotional theory, even when the evidence is thin. Not emotional in a loud way, but in the way an old stone wall in a field can make you wonder who stacked it, who walked past it, and whether they also complained about the weather, which, in the Baltic region, seems likely. Another theory placed the anomaly in the 20th century, among war, secrecy, and military experiments. This was almost inevitable. The Baltic Sea was strategically important during the Second World War and the Cold War. It saw naval activity, submarines, mines, patrols, aircraft, and military installations. So when a strange object appeared on the seabed, some people wondered whether it might be connected to wartime technology. Perhaps it was a piece of military equipment, perhaps a German device, perhaps a secret weapon, perhaps an anti-submarine structure, a listening station, a gun platform, a mine base, or some other discarded object from a tense period of history. This theory had a practical flavour. It did not need aliens or a lost civilization. It only needed humans being secretive, inventive, and occasionally very bad at cleaning up after themselves. The military theory is understandable because seas are full of human leftovers. Wrecks, anchors, cables, mines, dumped munitions, aircraft parts, and broken equipment can all end up underwater. Some are mapped, some are forgotten, some are dangerous. In a region with a complicated modern history, it would not be shocking to find man-made material on the seafloor, but again, the Anomaly's reported shape did not clearly match any known object. A military explanation would need specifics. What device would be 60 meters across and circular? What materials would it be made from? Why would it be at that location? Why would it produce the sonar appearance seen in 2011? Where are the records, fragments, markings, metal signatures, or associated debris? Military secret can be a tempting answer because secrecy explains the lack of information. But that also makes it too easy. If every missing detail is explained by secrecy, the theory can become impossible to test. And a theory that cannot be tested is not very useful, even if it looks wonderful in a dark coat. There were also ideas about dumped industrial material, or a man-made platform of some kind. These are less glamorous, but they deserve a place because they live closer to ordinary reality. Humans dump things. Humans build things near and in water. Humans leave behind concrete, metal, cables, dredging material and construction debris. An unusual sonar return could be something human-made without being ancient, alien, or military. It could be industrial, it could be waste, it could be equipment, it could be a collection of objects rather than one object. The difficulty, once more, is evidence. Samples and expert comments have not given strong support to a constructed modern object. If the site is mostly rock, then the simplest version of the industrial theory becomes weaker. But in the early period, before the natural explanation had settled into the public conversation, almost every artificial possibility was invited to the table. The table became crowded. Someone probably should have made name cards. One of the more dramatic claims involved unusual materials. Some reports suggested that samples from the site were strange, burnt-looking, or unusually hard. Others, including expert summaries, described the recovered samples as ordinary rocks such as granite, gneiss, sandstone, and basalt, materials consistent with natural geological processes and glacial movement in the region. This disagreement, or at least this difference in emphasis, kept speculation alive. If the samples were ordinary, the mystery cooled. If they were unusual, the mystery warmed up again. The problem is that material claims need careful handling. Where exactly was the sample taken? Was it attached to the formation or lying loose nearby? Was it collected under controlled conditions? Who tested it? Were the results published clearly? What did independent experts say? Without that chain of information, unusual material becomes another foggy window. You can see shapes through it, but it is risky to describe the furniture. Then there was the idea of a meteorite or impact feature. This theory moved the story away from technology but kept a sense of drama. Perhaps the circular feature was related to an impact from space, not a spacecraft, but a natural object such as a meteorite striking the area long ago. Round shapes and impact stories go together easily in the mind. A meteorite leaves a crater. A crater is round. The anomaly is round. Therefore, perhaps. But a true impact feature has signs. shocked minerals, melted rock, specific crater morphology, ejecta patterns, and geological context. A sonar image alone does not establish impact. Also, the Baltic seabed has been heavily modified by glacial processes, sedimentation, and water. A rounded feature there may have many possible natural origins that do not involve a fiery arrival from the sky. Still, the meteorite theory had one advantage over the UFO theory. Space rocks are real. They do fall to Earth. They do make marks. They just require evidence before being promoted from interesting thought to likely explanation. A smaller but persistent group of ideas involved natural gas, volcanic activity, or unusual chemical processes. These were usually attempts to explain not just the shape, but the alleged equipment problems or strange surface appearance. Could gases from the seabed affect instruments? Could minerals create magnetic interference? Could some unusual deposit produce odd readings? These questions are reasonable in a general sense. The seafloor can release gases. Mineral deposits can have magnetic properties. Underwater chemistry can produce surprising formations. But applying these ideas to this specific site requires measurements. It is not enough to say that nature can do strange things. One must show that this place is doing that particular strange thing. Otherwise, the explanation becomes a soft cushion where any mystery can lie down. The wildest theories, as always, had the least patience. Some suggested an ancient advanced technology, not quite alien, but not ordinary human either. Others connected the object to lost civilizations with no solid evidence linking those ideas to the Baltic site. There were claims of energy fields, entrances, hidden chambers, and large-scale cover-ups. At this point, the anomaly became less a seafloor feature and more a blank screen. People projected onto it whatever mystery they already preferred. Atlantis, secret bases, ancient astronauts, suppressed archaeology, hidden history, government silence, unknown power sources. It is amazing how much can be fitted inside a blurry sonar image if one folds the evidence small enough, and yet it would be too easy to laugh at all of this and move on. A gentler and more useful approach is to ask why these theories appeared at all. They did not come from nowhere. They grew from real uncertainty, limited images, difficult access, dramatic setting, and human pattern recognition. People are not machines waiting for peer-reviewed papers before forming impressions. We respond to stories. A round object under the sea feels meaningful because it resembles things we know. A trail beside it feels meaningful because it suggests movement. Equipment failures feel meaningful because they imply hidden force. Divers saying the site is strange feels meaningful because first-hand experience carries emotional weight. The theories are, in one sense, attempts to organize these pieces into a narrative. Some narratives are much weaker than others, but the impulse behind them is familiar. Science does something similar, but with stricter rules. It also tries to organize evidence into explanations. The difference is that a scientific explanation must survive tests, measurements, expert review, and comparison with known processes. It must not simply be exciting. It must account for the evidence without adding unnecessary assumptions. This is why the natural geological explanation has remained the most cautious and widely accepted. The Baltic seafloor has a known history of glacial shaping. Rock deposits, outcrops, moraines, and other formations can look unusual. The samples reported from the site did not clearly reveal exotic materials. The original sonar image was criticised as indistinct and potentially distorted. Those facts do not create a spectacular movie scene, but they do form a sturdy explanation. Theories like UFOs, ruins, and weapons are not all equal. Some are more plausible than others. A man-made object from recent human activity is far more plausible than an alien spacecraft, simply because we know humans have filled seas with objects. An ancient submerged structure is possible in a broad sense, because submerged archaeology exists, but it would need strong evidence at this particular site. A military object is possible in a broad Baltic context, but it would need matching design, material and records or debris. A crashed alien craft sits much farther away from established evidence and would require extraordinary proof. These distinctions matter. In mystery storytelling, all theories may sit beside each other for atmosphere. In investigation, they do not carry the same weight. There is also a lesson in how quickly unexplained becomes unexplainable. At first, the anomaly was unexplained because not enough was known. That is normal. Many things are unexplained at first. A doctor may not know what caused a symptom before tests. A mechanic may not know what is rattling until the bonnet is opened. A geologist may not classify a formation from one blurry image. But unexplained is a temporary description, not a supernatural category. It means we do not yet know. It does not mean no ordinary explanation is possible. The Baltic Sea anomaly was often treated as if the lack of immediate certainty was itself evidence for the most dramatic option. That is a common mistake. A gap in knowledge is not automatically a doorway for whatever theory arrives first with dramatic lighting. Still, the wild imagination around the anomaly has kept it alive in popular culture. Without those theories, it might have remained a small marine geology curiosity. A Swedish team finds odd sonar feature. Experts suggest glacial formation. End of article. Instead, the UFO comparisons, ruin theories, equipment claims, and military speculation turned it into a modern underwater legend. That does not make the claims true, but it does make the story culturally interesting. The anomaly became a case study in how mysteries are built in the internet age. A real image becomes a viral comparison. A cautious statement becomes a dramatic headline. A difficult dive becomes evidence of strangeness. A natural explanation becomes to some a cover-up or a disappointment. The story grows not only from the seabed, but from the way people talk about the seabed. It is worth remembering that wonder and skepticism do not have to be enemies. Wonder says, "Look at this strange thing." Skepticism says, "Let us be careful about what we claim." Wonder opens the door. Skepticism checks whether there is a staircase on the other side before everyone walks through. The Baltic Sea anomaly needs both. Without wonder, nobody would care. Without skepticism, the object becomes whatever the loudest theory says it is. A calm approach allows us to enjoy the mystery without handing over the keys to every passing idea with a shiny cover story. So the theories began, and they multiplied because the evidence left room for them. A possible UFO for those who looked upward, a ruin for those who looked backward, a weapon for those who looked into recent human conflict, a meteorite for those who wanted a natural event with drama, a geological formation for those who looked at ice, rock, and the long history of the Baltic basin. Each theory tried to answer the same quiet question from a different direction. What makes a large, round-looking shape on the seafloor, in a place shaped by both human history and ancient ice? The next step is not to choose the most exciting answer, nor to dismiss the mystery because some of the theories ran too far. The better path is to ask what the seafloor itself can do, what glaciers can leave behind, what rocks look like after being dragged, cracked, buried, and exposed, what sonar does to slopes and shadows, what happens when natural forms appear in unnatural-looking shapes. Because once the louder theories have had their turn, the slower explanation begins to move forward, not with flashing lights, not with secret doors, but with ice sheets, stone, pressure, and time, which have always been very good at building strange things without asking for applause. Once the louder theories had taken their turn, the investigation had to slow down and do something much less dramatic, but much more useful. It had to ask what the Baltic seafloor itself was capable of making. That may sound like a small question, but it is not. The bottom of the Baltic Sea is not just mud with a few stones scattered around for decoration. It is a record of ice, pressure, erosion, melting, rising land, moving sediment, and thousands of years of quiet physical change. If you want to understand a strange shape down there, You cannot only ask what it looks like, you have to ask where it sits, what the region is made of, how the bottom was shaped, what moved across it before the sea covered it, and whether similar shapes exist nearby. In other words, before calling something an object, scientists first ask whether it might simply be part of the landscape. This is where the story becomes less like a mystery film and more like a geology lesson conducted in a very cold room. But stay with it, because geology is often stranger than it sounds. It does not usually burst through the door waving a flashlight, but given enough time, it can carve valleys, move boulders across continents, grind mountains into sediment, and leave behind shapes that look suspiciously organised. If humans are good at building structures, nature is good at making structures by accident and then refusing to explain itself. The Baltic Sea region was heavily shaped by the last ice age. For a long period, huge sheets of ice covered northern Europe. These were not little patches of winter frost. These were enormous masses of ice, thick, heavy, and slow, pressing down on the land and moving across it with enough force to scrape bedrock, drag stones, crush material, and reshape entire landscapes. A glacier is not just frozen water sitting politely in one place. It is more like a slow, moving machine made of ice, rock, and pressure. It can pick up boulders, carry them far from where they began, grind surfaces beneath it, and leave behind piles and ridges when it melts. It moves slowly enough that no one would call it lively, but with enough strength that a mountain would prefer not to be in its way. When the ice eventually retreated, it did not leave behind a tidy floor. It left behind scars, ridges, deposits, basins, and scattered rocks. Some material was carried from far away. Some was scraped from nearby bedrock. Some was crushed into clay and sand. Some remained as larger stones. Over time, water filled the basin that became the Baltic Sea, and sediment settled over the old glacial landscape. But the marks did not vanish. Many remained under the water, hidden from view, waiting for sonar to pass over them thousands of years later and make humans argue on the internet. That glacial history matters because it gives scientists a ready natural toolkit. A rounded mound on the seafloor could be a rock outcrop. It could be a glacial deposit. It could be part of a moraine, which is material left behind by a glacier. It could be a drumlin-like form, shaped by moving ice. It could be a collection of rocks arranged by natural processes. It could be sediment over harder material. It could be many things that do not require a builder, pilot, secret weapon designer, or ancient engineer with a taste for circular floor plans. This does not mean scientists simply wave at the word glacier and go home. A good natural explanation still has to fit the evidence. But the Baltic gives geology a strong starting position. If an unusual stone feature appears in a region known for glacial shaping, then glacial shaping deserves serious attention. It is not an excuse. It is a context. It is the difference between finding flour on a kitchen counter and finding flour in a bedroom. In the kitchen, flour may not be exciting, but it makes sense. On the Baltic seafloor, strange rock arrangements may not be fully explained at first glance, but the region has a long history of making them. The rock samples reportedly recovered from the site became an important part of this search for a natural explanation. Samples are not perfect, especially underwater, because the exact position and attachment of each piece matters. A stone picked up from near a feature might not be part of the feature itself. It could be loose material resting nearby. It could have been transported by ice. It could have been dropped, shifted, or exposed. But samples are still useful because they tell scientists what kinds of materials are present. If the pieces had contained strange alloys, manufactured layers, tool marks, or materials not expected in nature, the artificial theories would have gained weight. Instead, the reported analysis pointed toward ordinary rocks: granite, gneiss, sandstone, basalt. These are not dull words if you give them a moment. Granite forms deep underground from cooled magma. Gneiss is a metamorphic rock, changed by heat and pressure until its minerals form bands and patterns. Sandstone begins as sand, compacted and cemented over time. Basalt comes from volcanic rock, dark and dense, often formed from cooled lava. On their own, these materials are not signs of machinery. They are signs of Earth being Earth for a very long time. Finding them near the anomaly does not automatically explain the full shape, but it does make the more dramatic theories work harder. A supposed craft or building made mostly of ordinary glacial rocks is less convenient for anyone hoping to find the spare parts of a hidden engine. The basalt detail attracted attention because basalt can seem unusual in that setting. A dark volcanic rock on the seafloor sounds at first like a clue wearing a serious expression. But rocks can travel. Glaciers are very good at moving stones from one place to another. They can pick up material, carry it, and deposit it far from its origin. A rock being out of place does not mean it is impossible. It may simply mean the ice had a long day. In a heavily glaciated region, mixed rock types are not surprising. They are part of the record of movement. The glacier did not sort everything neatly into labelled boxes. It carried what it carried, dropped what it dropped, and left later humans to make sense of the mess. The chemical and mineral evidence also mattered because some public claims described unusual or burnt-looking material. That kind of wording can quickly feed theories of impact, heat, engines, or artificial construction. But minerals such as limonite and goethite, which can produce rusty, dark, or altered surfaces, can form naturally. A strange-looking surface is not always a burned surface. A hard piece of rock is not always manufactured. A dark patch is not always the scar of some powerful event. Natural chemistry can be surprisingly good at making ordinary materials look suspicious, rather like a harmless old suitcase that somehow looks guilty under airport lighting. Then there was the sonar problem. Scientists and sonar specialists were cautious, because the original image was not high quality enough to carry the heavy claims placed on it. This is a practical issue, not a philosophical one. If the image is distorted, low resolution, or taken from a limited angle, then details can mislead. A rounded mound can look like a disc. A shadow can look like a hole. A rough edge can look straight. A cluster of stones can look like one solid structure. If the equipment was not ideal, or if the data was processed in a way that emphasized certain shapes, the image could appear more artificial than the actual sea floor. This is why scientists often want more than one scan. They want different angles, better resolution, accurate positioning, and comparison with the surrounding area. One sonar pass can make a feature look isolated. A broader survey may show that it is part of a larger pattern. One image can make a nearby line seem like a trail. Regional bathymetry, which maps underwater depth and shape, may show that the so-called trail belongs to a group of natural ridges or mounds. That is a very different story. A mysterious runway leading to a circular object sounds strange. A natural ridge among many similar ridges sounds like geology doing its usual work, which is less thrilling, but more likely to be invited to a scientific conference. A natural explanation also asks whether the anomaly is attached to the seabed or separate from it. This is important. An artificial object like a wreck or machine would likely be a distinct thing resting on top of the bottom, unless buried. A rock outcrop or glacial formation may be part of the bottom itself. It may not have an underside in the way people imagine. It may not be something that could be lifted away. It may be more like a hill than an object. The public name, Anomaly, is neutral, but the public habit of calling it an object quietly pushes the mind towards something placed there. Scientists prefer to check whether that assumption is even correct. If the feature is a rock outcrop, its apparent shape could come from erosion, sediment cover, and fractures. Rock does not break randomly in every case. It often has weaknesses, layers, joints, and planes. These can create edges that look clean. Under sonar, those edges may appear even cleaner. If sediment fills some cracks and hides others, the surface may look smoother and more designed than it really is. Seen in darkness by divers, a flat section of rock can feel like a floor. A ledge can feel like a step. A fractured wall can feel like something cut. But none of these impressions prove human work unless they are accompanied by stronger signs of construction. If the feature is a glacial deposit, the explanation becomes slightly different. A glacier can leave behind a pile of mixed material, sometimes compacted, sometimes shaped by movement or meltwater. Such deposits can form mounds and ridges. They can include rocks of different origins, carried from elsewhere. They can be covered by finer sediment after the sea forms. A sonar image of such a deposit might show a rounded or raised feature with unusual texture. If the surrounding seabed is softer, the harder deposit may stand out. From a distance, that contrast can look like an object. Up close, it may be a jumble of stone and sediment with no clear artificial plan. There is also the possibility that more than one natural process contributed to the appearance. This is often how real landscapes work. A rock outcrop may be shaped by ice, then covered partly by sediment, then modified by currents, then revealed by erosion, then scanned by sonar from one angle. By the time humans see the final result, it may not be easy to say one process made it. Nature does not always use a single tool and then put it back in the drawer. It stacks processes on top of each other. That can produce forms that look more complicated than a simple explanation suggests. A careful scientific approach, therefore, does not need to find one magical natural cause. It can say that the feature is likely natural because the materials, region, and imaging limits all point that way, while still admitting that the exact formation history may not be fully mapped. That distinction is important. Saying likely natural is not the same as saying every detail has been explained down to the last pebble. People sometimes treat these as the same thing. They are not. A doctor can say a cough is very likely caused by a cold without knowing the precise path of every virus particle. A mechanic can say a car problem is likely electrical before tracing every wire. A geologist can say a seabed feature is likely glacial or rocky without producing a complete biography of the rock by tea time. The public, however, often wants a complete biography. It wants the sentence that closes the case. This is a glacial deposit formed by a retreating ice sheet at this exact time, shaped by this process with this trail made by this known event. That would be satisfying. It would also require detailed study. Without a full published survey, the natural explanation can remain broad. And when an explanation is broad, mystery has a room to breathe. This is why some people continue to say scientists still cannot explain the anomaly. In a narrow sense, the precise origin may not be fully described in public data. In a broader sense, scientists have a strong category of explanation: natural geology shaped by ice and sediment. The gap between those two meanings is where many arguments live. There is also a difference between not artificial and not interesting. Natural features are often treated as the boring answer, as if a glacier moving stones across northern Europe is somehow less impressive than a secret machine. But imagine the scale involved. Ice sheets covering land, the weight pressing the crust downward, rock being scraped and carried, the climate shifting, ice retreating, water filling the basin, land rising slowly after the ice melted, a process called post-glacial rebound, sediment settling through cold water, thousands of years passing while the feature sat unseen. Then a boat crosses overhead, sends sound downward, and turns that deep history into a strange grey shape on a screen. That is not boring. It is just not wearing a silver jumpsuit. The scientific search also had to deal with claims about electronic interference. A natural explanation has to treat those carefully, because if strong, repeated, measured interference were confirmed, it might suggest unusual minerals, cables, equipment, or some other factor. But public stories of devices failing are not the same as controlled measurements. Scientists would want magnetometer readings, repeat tests, environmental conditions, device logs, and comparison away from the site. Without that, equipment problems remain weak evidence. They may have happened. They may have ordinary causes. They may have been exaggerated in retelling. At sea, Devices fail for many reasons. The Baltic does not need mysterious energy to make electronics behave badly. Moisture and cold can manage quite well on their own. The same careful attitude applies to the claimed temperature changes near the object. A temperature difference sounds intriguing, but underwater temperatures can vary because of currents, layers of water, depth, seafloor conditions, or measurement issues. A local change is not automatically evidence of a hidden power source. It may be a normal water column effect or a sampling problem. Again, the solution is not to dismiss the claim with a wave. The solution is to measure it properly. Is the change real? Is it repeatable? How large is it? Does it appear elsewhere? Does it match known Baltic water patterns? This is the slower rhythm of science. It does not reject every unusual claim. It asks the claim to stand still long enough to be tested. A useful comparison is a strange noise in a house at night. The first story your mind creates may involve intruders, ghosts, or some creature in the wall, making plans. A calmer search checks the pipes, the wind, the heating system, the refrigerator, and the cat, who, let us be honest, has been suspiciously quiet. Most of the time the answer is ordinary, but ordinary does not mean the noise was imaginary. It means the cause was not the first dramatic story the mind produced. The Baltic Sea anomaly works in a similar way. The sonar shape was real. The sight was real. The question was real. The first dramatic stories were not therefore automatically correct. As scientific explanations developed, the anomaly became a test of patience. The natural answer did not arrive with one stunning image. It arrived through context, known glacial history, ordinary rock samples, limitations of sonar, lack of clear artificial materials, and the ability of natural formations to appear geometric. Each point reduced the need for extraordinary explanations. None of them alone may satisfy every listener, but together they make a strong case. That is often how real explanations work. Not one thunderclap, but many small weights placed on one side of the scale. There is a certain comfort in that. A mystery does not have to be solved by destroying wonder. It can be understood by placing it inside a larger story. The Baltic Sea anomaly may not be a crashed craft, a lost temple, or a secret weapon. It may be a natural feature shaped by ice and stone. But that still places it inside a story far older than any internet theory. It connects the object not to a sudden crash, but to the slow work of a frozen continent, not to hidden engines, but to pressure and retreat, not to a single dramatic event, but to a chain of natural events so large that human imagination struggles to picture them all at once. And this is where the scientific search becomes quietly satisfying. It does not say, stop wondering. It says, wonder more accurately. Wonder about the Ice Age. Wonder about how a glacier carries basalt into a place where it seems out of place. Wonder about how sonar turns rough stone into a strange circle. Wonder about how quickly the brain recognizes a familiar shape where the data is incomplete. Wonder about why the seafloor is still less familiar to us than the surface of some distant worlds. That is not less interesting. It is simply less noisy. The natural explanation does not need the anomaly to be fake. It does not need the Ocean X team to have seen nothing. It does not need divers to be dishonest. It only needs the simplest reading of the evidence to be that the feature is part of the Baltic's geological history. A real formation. A strange-looking formation. A formation that became famous because of one sonar image and a public appetite for the unknown. That explanation is modest, but it fits the available pieces better than the dramatic alternatives. Still, even a likely natural answer leaves room for further study. Better mapping could show the full shape. More samples taken under controlled conditions could clarify the material. Independent surveys could compare it with nearby seabed features. A three-dimensional model could help separate real geometry from sonar distortion. The question is not impossible to study. It is simply expensive, technical, and perhaps less urgent once the evidence points toward geology. Science has limited time and money, and the world is full of rocks that look strange without being headline material. Somewhere, a very ordinary boulder is probably grateful not to have gone viral. So the search for a natural explanation did not remove the Baltic Sea anomaly from the world of mystery all at once. It changed the type of mystery. Instead of asking whether it was a spacecraft or a ruin, it asked how ice and stone can create a shape that fools the eye. Instead of asking what secret is hidden inside it, it asked what history is written into it. The object became less like a visitor and more like a local resident with a long past, less like a machine waiting to be opened and more like a piece of seafloor waiting to be understood. And once the story turns in that direction, the Baltic itself becomes the main character, not the headlines, not the wild theories, not the blurry comparison to a fictional spacecraft. The sea and the land beneath it, the ice that once covered the region, the rocks carried from one place to another, the sediments laid down after the melt, the cold water that kept the feature hidden until sound waves found its outline. To understand the anomaly, we have to step even farther back, long before Ocean X, long before divers, long before ships crossed those waters, to the time when ice moved over northern Europe and began shaping the floor of a sea that did not yet exist in the form we know today. Long before a sonar screen showed a strange shape in the Gulf of Bothnia, long before divers dropped through the cold water with lamps and cameras, and long before anyone online compared the outline to a spacecraft, the place where the anomaly rests was part of a much larger story, not a story written by people, ships, or machines, but by ice, heavy ice, slow ice, ice thick enough to press the land down beneath it and patient enough to reshape stone without ever needing to hurry. The Baltic Sea did not begin as the sea we know today. It passed through stages after the last ice age, as the climate warmed, the Scandinavian ice sheet melted, and water filled the low basin left behind. At different times, parts of the region were covered by meltwater lakes, connected to the ocean, cut off again, flooded, drained, and changed by rising land. The shape of the Baltic was not fixed. It shifted, opened, closed, and adjusted over thousands of years. Coastlines moved, islands appeared, low areas became water, former seabeds rose into dry land. The whole region behaved less like a finished map and more like a slow construction site where the workers were ice, water, gravity, and time, none of whom seemed especially concerned about leaving clear instructions behind. That matters for the anomaly because the seafloor beneath the Baltic is not plain. It is not a flat underwater desert waiting for one strange object to stand out cleanly. It is a complicated surface made from bedrock, sediment, glacial deposits, ridges, hollows, loose stones, and old marks left by moving ice. If you could drain the Baltic Sea for a moment, which would be a very inconvenient afternoon for fish, shipping lanes, and everyone with a coastal property, the bottom would not look like a smooth floor. It would look like a landscape. There would be rises and dips, scraped surfaces, scattered boulders, and places where old geological layers meet newer sediment. Some parts would look ordinary, some would look broken, some would look oddly arranged even though no one arranged them on purpose. A glacier is one of nature's strongest tools. It can move across land so slowly that a person watching it would see almost nothing happen, but the effects over centuries and millennia are enormous. The ice carries stones inside it and beneath it. It grinds rock surfaces. It scrapes lines into bedrock. It pushes loose material into ridges. It leaves behind mixtures of clay, sand, gravel and boulders when it melts. This mixed material is called till, and where it collects in long ridges or mounds it can form moraines. These are not neat features in the way a wall or road is neat, but they can still have shape. They can still make patterns. They can look surprisingly deliberate when sonar catches them from the right angle. The northern Baltic, including the Gulf of Bothnia, is especially connected to this glacial history. The weight of the old ice sheet pressed the crust downward. When the ice melted, that weight was removed and the land began to rise again. This is called glacial isostatic adjustment, or post-glacial rebound. It is still happening today. In the Gulf of Bothnia region, the land is rising fast enough that new land continues to appear along parts of the coast over time. This is not a legend or a mystery claim. It is measured. The old ice is gone, but the land is still reacting to it, like a mattress slowly lifting after a very large guest finally got up. That slow rise gives the region a special character. Places that were once seabed can become shore. Shores can become inland ground. Harbours that worked in one century may become too shallow later. Islands can grow closer to one another as land rises and water retreats from low areas. The Baltic is not only a body of water, it is part of a moving system. Very slow, yes, but moving all the same. This is the kind of place where the past does not stay politely behind us. It is still adjusting under people's feet and under the water. So when scientists look at a strange shape on the Baltic seafloor, they do not begin with empty space. They begin with ice. They begin with bedrock. They begin with the knowledge that stones may have been carried from one place to another by glaciers. They begin with the fact that hard rock can be exposed in some places and buried under sediment in others. They begin with moraine ridges, glacial till, and seabed deposits that can form raised, irregular shapes. A circular-looking feature does not need to have fallen from the sky. It may have been built slowly by natural processes that were never aiming to make anything recognizable. This is where the Baltic Sea anomaly becomes less like an isolated object and more like one small piece of a much larger floor. The first sonar images made it seem separate. They gave viewers a shape to focus on, a round form, a possible trail, a strange outline. But landscapes often look different when seen out of context. A hill photographed from above may seem like a perfect mound. A section of cliff may look like a wall. A rock ledge may look like a platform. If the surrounding area is not mapped in enough detail, one feature can seem more unusual than it really is. It is a bit like finding one oddly shaped biscuit in a tin and forgetting that the entire tin has been through a rough journey in the back of a delivery van. The rocks reportedly found near the Anomaly also point back toward this old glacial setting. Granite, gneiss, sandstone, basalt, and other ordinary rock types do not sound like the pieces of a machine. They sound like the materials of a region shaped by geology. Some may come from bedrock, some may have been transported, some may have been dropped by ice as it melted. A glacier does not carry only one kind of stone. It collects material as it moves, and can leave a mixed pile behind. This is why a dark basalt piece, or a stone that seems out of place, does not immediately require a dramatic explanation. It may simply have been moved there by ice, which is nature's very slow removal company. Rock can also break in ways that look artificial. This is one of the easiest things to forget. Human-made objects often have straight lines, flat planes, and sharp edges. So when we see those features in nature, we become suspicious. But rock often fractures along weaknesses. Layers can split. Pressure can create cracks. Weathering and erosion can open surfaces. Underwater, sediment can hide the messy parts and leave only the cleaner-looking edges visible. Add sonar shadows, poor visibility, and a public already expecting something strange, and a fractured rock surface can begin to look like a built structure. Nature does not need to carve perfect sculptures to mislead us. It only needs to create a few lines that our brains recognize too quickly. Flat surfaces are another source of confusion. A diver touching a hard, level area might describe it as floor-like. That can sound artificial, but flat rock surfaces occur naturally, especially where layers, bedding planes or fractures are exposed. Sediment can also settle over uneven ground and create smoother patches. A flat patch on the seafloor is not automatically a floor in the human sense. It may be a natural surface that happens to be level enough to feel unusual under a diver's hand. The difference matters because one description belongs to experience and the other belongs to interpretation. It felt like a flaw is not the same as it was a flaw. The same applies to features described as steps, walls, grooves, or ramps. These words are useful because they help people imagine what a diver saw, but they can also smuggle in assumptions. A step sounds built for feet. A wall sounds built to divide space. A ramp sounds built for movement. In geology, the same shapes might be called ledges, fractures, slopes, ridges, or bedding planes. The physical feature may be real, but the word changes the mood. A ledge is geological, a step is architectural, a crack is natural, a seam may be either. A wall is already halfway to a ruin in the imagination. The anomaly has been pulled back and forth by this language for years. The apparent trail or track near the object can also be read through glacial history. A long mark on the seabed may look like evidence that something slid or crashed, but glaciers can leave long marks too. Moving ice can scrape bedrock. Stones trapped beneath ice can gouge surfaces. Sediment can be pushed into lines. Later currents and seabed processes can emphasize certain shapes while softening others. A line on the bottom does not need to be a path made by the object beside it. It may be older, unrelated, or part of a larger pattern not visible in the famous cropped images. This is one of the reasons broader mapping matters. A dramatic mark beside one feature may look unique until the surrounding seafloor is shown to have many similar marks. There is another possibility that sounds less exciting but fits the way real seabeds behave. The anomaly may not have one simple origin. It could be bedrock shaped by ice, partly covered by glacial till, modified by sediment, and then highlighted by sonar in a way that makes the final shape look more regular than it is. Natural features often have layered histories. One process begins the form, another changes it, another hides part of it, another reveals it again. By the time sonar finds it, the feature is the result of several events, not one clean moment. This is why the idea of a single dramatic crash can be so tempting. It is simple. One event, one object, one story. Geology often says, not quite. Here are 5 processes, 3 time periods, and a lot of mud. The Baltic Basin's changing water history adds even more complexity. After the ice retreated, the region went through different water stages as connections to the ocean opened and changed. Freshwater and brackish conditions shifted. Sea level and land level did not move in one simple way everywhere. In the north, land uplift has been especially important. This means some features now underwater may have experienced different conditions in the past. They may have been exposed, submerged, affected by waves, covered by sediment, or altered by changing currents. The seafloor we see now is not just a frozen snapshot from the end of the Ice Age. It is a surface that has continued to change. That continued change can preserve odd features in some places and soften them in others. Hard rock may stand proud while softer sediment moves around it. A mound may remain visible because currents do not completely bury it. A depression may collect finer material. A ridge may cast a strong sonar shadow. A harder patch may resist erosion while surrounding areas become smoother. The result can be a feature that looks placed on the bottom, even if it is simply the part that resisted change better than everything around it. If the surrounding seafloor is lower, softer, or smoother, the hard feature will stand out. Standing out is not the same as being artificial. It only means the area is not uniform. This is one of the quiet lessons of geology. Nature creates contrast, hard beside soft, smooth beside rough, raised beside flat, dark beside light. When a sonar image captures contrast, the eye looks for meaning. We see borders, we see objects, we see design. But sometimes the border is only where one material changes to another. Sometimes the object is simply a harder part of the ground. Sometimes design is only the human brain being eager after a long day. The Baltic Sea anomaly sits at the meeting point of these habits. The seafloor has real complexity. The sonar image had real ambiguity. The human mind added real interpretation. None of these parts alone explains the whole public reaction, but together they do. A glacially shaped seabed can produce strange features. Sonar can make those features look cleaner and more dramatic. People can then compare them to familiar machines, ruins, or tracks. The mystery grows from the overlap. There is no shame in being fooled by nature. Nature has been fooling human eyes for as long as people have had eyes to fool. We see faces in cliffs, animals in clouds, towers in eroded stone, and paths in dry riverbeds. On Mars, people once saw a face in a mesa because the lighting and resolution created a familiar pattern. Later, better images showed it was just a hill. The hill was still real. The face was not. The Baltic anomaly may belong to the same family of cases. The formation may be real, large, and interesting. The spacecraft, ruin, or machine may be the face we added to the hill. At the same time, calling it natural should not be treated as a final shrug. A natural formation can still deserve careful mapping. It can still teach something about local geology. It can still be unusual in its exact shape. Scientists do not have to choose between ordinary rock and world-changing object. There is a middle ground where a feature is natural but still worth understanding. The Baltic seafloor holds many records of past ice, movement and changing shorelines. Each ridge, mound and deposit can add detail to the history of the basin. Even if the anomaly is not artificial, it may still be a useful marker of the processes that formed that part of the seabed. This is especially important because the sea hides geology from everyday view. On land, strange formations become landmarks. People name them, climb them, photograph them, and build snack bars nearby if enough tourists arrive. Underwater, similar features can remain unknown. A rock formation the size of a building may sit in darkness for thousands of years with no name at all. It only becomes famous if sonar crosses it, if someone notices, and if the shape is odd enough to escape the filing cabinet of routine survey data. The Baltic Sea anomaly may be famous not because it is the strangest thing down there, but because it was noticed in the right way at the right time. The more we consider the Ice Age background, the less lonely the anomaly becomes. It is not a mysterious circle floating in an empty void. It is part of a northern landscape that has been pressed, scraped, flooded, lifted and covered. The old ice shaped the region at a scale much larger than any single object. It built and broke surfaces. It moved rocks across distance. It left deposits that later became seabed features. It set in motion land uplift that still continues today. The anomaly, if natural, is one small result of that long chain. And there is something satisfying about that. A crashed craft would make the anomaly sudden. A ruin would make it human. A weapon would make it historical in a narrow modern way. But a glacial formation makes it old in a deeper sense. It connects the shape to the end of an ice age, to a time when the Baltic basin was still becoming itself. It says the object is not a visitor to the seafloor. It is a product of the forces that made the seafloor. It did not arrive in the Baltic. The Baltic, slowly and unevenly, made the conditions for it. This does not remove every uncertainty. The precise form of the anomaly, the exact nature of the nearby marks, and the full three-dimensional shape would still benefit from high-quality independent mapping. But the scientific direction is clear enough to be useful. The materials reported from the site are not exotic. The region is known for glacial geology. The sonar image was limited. The seafloor can create strange shapes. The simplest explanation remains that the anomaly is natural, even if its famous image made it look like something more dramatic. The important word there is simplest, not easiest. A natural explanation is simple in the scientific sense, because it uses known processes already present in the region. It does not need a crash, a lost civilization, secret machinery or unknown technology. But it is not easy in the everyday sense, because the real processes are vast, slow and layered. understanding them takes more patience than believing in a single dramatic event. It takes more time to explain glaciers than to say spaceship. It takes more effort to map sediment than to say ancient ruin. The natural answer is quieter, but it carries more weight. As the story moves from ice and stone back toward the public mystery, one thing becomes clear. The anomaly refuses to vanish because it lives in two places at once. It lives on the Baltic Sea floor, as a real formation shaped by real materials. It also lives in human imagination, as a circle in the dark that looked too strange to ignore. Science can speak strongly about the first place. It can describe rocks, glacial deposits, sonar limits, and seabed history. The second place is harder. Once people have pictured a hidden craft or forgotten structure, that image does not sink easily. It stays afloat, carried by curiosity, doubt, and the feeling that somewhere below cold water, the sea may still be keeping a larger secret. That is why the Baltic Sea anomaly refuses to vanish completely. It has been given a reasonable natural explanation, or at least the outline of one, but it has never been given the kind of clean public ending that makes everyone put down their cup of tea and say, well, that settles it. A likely explanation is not always the same as a satisfying explanation. And human beings, being what we are, often prefer a strange loose thread to a neatly folded answer, especially when the loose thread is lying 90 metres under cold northern water and looks a little bit like a spacecraft if you tilt your head and allow your imagination to wear its evening shoes. The mystery continues because it sits in that awkward space between explained and explained enough. Scientists can say the feature is probably natural. They can point to glacial history, ordinary rock samples, poor sonar quality, and the ability of the seabed to produce strange shapes. That is a strong case. But the public memory of the anomaly is not built only from the scientific case. It is built from the first image, the circular shape, the supposed trail, the reports of equipment problems, the dark water, the divers' descriptions, and the feeling that something about the site looked out of place. Those pieces are not all equally strong, but they are memorable. And in popular mysteries, memorable details often survive longer than careful explanations. One reason the anomaly stays alive is that the first image did exactly what a mystery image needs to do. It showed enough, but not too much. If the sonar picture had been sharper, the story might have ended quickly. A clear view might have shown a rock outcrop, a mound, a pile of glacial stones, or some other ordinary formation. People might have been briefly interested, then wandered away to argue about something else on the internet, as is tradition. If the image had been worse, perhaps no one would have cared at all. But it landed in the middle. It was just clear enough to suggest a round feature, and just unclear enough to let people complete the shape for themselves. That is a powerful combination. A blurry image gives the imagination room to help. And imagination, while charming, is not always a licensed surveyor. The comparison to the Millennium Falcon also gave the anomaly a simple public identity. Most geological features do not become famous because they do not have an easy shape people can remember. A mound of glacial till does not usually leap into conversation at dinner, but a strange underwater shape that looks, even loosely, like a famous spaceship is much easier to repeat. The comparison turned a technical sonar oddity into a cultural object. People who knew nothing about Baltic geology could still understand the basic idea. There is something round under the sea, and it looks like a spaceship. That sentence travels. A possible glacially influenced seabed formation with ambiguous sonar characteristics does not travel quite as well, though it does sound like it would bring excellent notes to a meeting. The story also refuses to sink because the sea itself keeps the evidence at a distance. If the anomaly were on dry land, it would be much harder for speculation to survive. Researchers could walk around it, map it, photograph it from every side, drill it, sample it, scan it, and invite other specialists to look at it. Someone would probably have flown a drone over it within an hour. A tourist might have dropped a sandwich on it by the end of the first week. But underwater, everything becomes more difficult. The depth, the darkness, the cost of expeditions, the poor visibility, and the need for specialized equipment all protect the mystery from becoming too ordinary too quickly. The object or formation is not impossible to study, but it is inconvenient to study. Inconvenience is one of mystery's best hiding places. There is also the problem of incomplete follow-up. The Ocean X team returned, divers went down, samples were discussed, and experts commented, but the public did not receive a single, definitive, independent, high-resolution survey that everyone could easily understand. There was no widely accepted three-dimensional model passed around with a calm explanation saying, "Here is the feature, here is what it is made of, here are similar formations nearby, and here is why the famous image looked so strange." Without that kind of public closure, the mystery remains available. People can always say, yes, but have they really mapped it properly? Have they really sampled the right part? What if the stones came from nearby but not from the structure? What if the most important section is still buried? These questions are not all unreasonable, but they can keep moving the finish line. That moving finish line is very common in unexplained object stories. At first, people ask what the image shows. Then, when experts suggest a natural explanation, the question shifts to why the shape looks so regular. Then samples show ordinary rock, and the question shifts to whether the samples were taken from the correct spot. Then the sonar quality is criticised, and the question shifts to why the divers reported odd experiences. Then the equipment claims are questioned, and the question shifts to why no one has done a larger expedition. Each answer closes one door, but another smaller door appears nearby, usually with a creaky hinge and a sign saying, "Just one more possibility." The word unexplained does a lot of work here. It sounds simple, but it can mean different things. It can mean no one has any idea what something is. It can mean the exact formation process has not been fully described. It can mean the public has not seen enough evidence to feel satisfied. It can mean experts disagree. It can also mean that an ordinary explanation exists, but some people do not like it very much. The Baltic Sea anomaly is often called unexplained because the exact details remain uncertain in public discussion, not because every natural explanation has failed. That distinction matters. A strange rock formation can be partly unexplained and still probably natural. The universe is full of things that are not fully mapped, fully sampled or fully understood in every detail, and most of them are not spacecraft. Some of them are just rocks having a very successful public relations campaign. Another reason the mystery stays afloat is that it offers a rare combination of safety and strangeness. It is mysterious but not too frightening. There is no creature rising from the water, no danger to the listener, no haunted room, no cursed object sitting at the end of the bed. It is distant, it is quiet, it rests under the sea. That makes it easy to explore mentally. People can wonder about it without feeling threatened by it. It has the mood of a puzzle rather than a nightmare. Even the wild theories feel softened by the water above them. A crashed object at the bottom of the Baltic sounds strange, but also still. It is not chasing anyone. It is simply lying there, being discussed by people with laptops. The setting gives the story more weight than it might have had elsewhere. The Baltic Sea has history. It has old trade routes, wars, shipwrecks, submarines, fishing grounds, and coastal cultures shaped by cold water and changing seasons. When an anomaly appears in that kind of place, it can attach itself to many different kinds of stories. It could be geological, it could be historical, it could be military, it could be ancient, it could be modern debris. The sea has enough real secrets that even a doubtful mystery feels slightly more plausible there. We know ships have sunk in it. We know people have fought across it. We know the Ice Age shaped it. We know parts of its bottom are not familiar to everyday human eyes. A strange shape in the Baltic does not feel random. It feels as if it belongs to a long catalogue of things the sea has kept. The equipment failure stories help the mystery more than almost anything else after the image. Even if those claims are weak as evidence, they are strong as storytelling. devices failing near a mysterious underwater formation feel important. The detail makes the site seem active, not merely odd-looking. A rock formation can be strange, but an object that makes equipment misbehave sounds like it is doing something. That changes the mood. It suggests energy, interference, magnetism, hidden machinery, or some force not yet understood. Of course, electronics fail at sea for ordinary reasons all the time. Water, cold, salt, batteries, connectors, pressure, and bad luck are perfectly capable of ruining a working day. But in a mystery, timing matters emotionally. If a camera fails near a normal rock, it is annoying. If it fails near a famous anomaly, it becomes part of the legend. The human mind also has a hard time accepting that nature can look artificial. We often treat straight lines, circles, flat surfaces, and repeated shapes as signs of design. That instinct is useful in daily life. It helps us recognize tools, buildings, paths, and signs of human activity. But geology regularly produces shapes that look planned. Basalt can form columns. Crystals form orderly structures. Rock layers split into flat sheets. Erosion creates arches, towers, and ledges. Glaciers carve grooves and leave ridges. Concretions form rounded stones. From one angle, a natural formation can look like a wall, road, platform, or even a machine part. The problem is not that our brains are bad. They're doing what they are built to do. They detect patterns. They just sometimes detect them too eagerly, like a dog hearing the word walk in a sentence that was not meant for it. The Baltic Sea anomaly is especially good at triggering that instinct. A round-looking form, a hard surface, possible lines, a nearby mark, reports of flat areas. It contains several cues that humans associate with design. The natural explanation asks us to override that first impression and think in terms of glacial deposits, rock fractures, sonar distortions, and sediment. That is harder. The artificial explanation is immediate. It looks built, therefore maybe it was built. The geological explanation takes longer. It has to explain why something can look built without being built. And in popular culture, the quicker explanation often gets to the microphone first. Trust plays a role too. Some people distrust official or expert explanations, especially when those explanations arrive after a story has already become exciting. If the first version someone hears is mysterious underwater UFO, then a later explanation of likely natural formation can feel like a downgrade, or even a cover-up depending on the listener's habits. This is not unique to the Baltic Sea anomaly. It happens with many mysteries. The exciting version makes the first emotional impression. The cautious version arrives carrying a folder. The folder may be correct, but it does not always win the room. The story also benefits from the fact that no one has produced the opposite kind of spectacular proof. There is no famous image showing a diver standing beside an obviously ordinary rock face with labels and measurements that make the public laugh at the earlier claims. There is no simple visual debunking that has become as iconic as the original sonar image. The first mystery image remains the image people remember. Later explanations are mostly words: glacial deposit, natural formation, sonar distortion, rock samples. Words are useful, but images are sticky. A strange picture can outlive a careful paragraph. That is why the anomaly keeps returning in articles, videos, forums, and documentaries. The picture still does its work. Money and media attention may also have played a part in keeping the mystery alive. Underwater exploration is expensive, and a dramatic mystery attracts more interest than an ordinary seabed feature. That does not mean the original discovery was fake, and it does not mean everyone involved acted in bad faith. It simply means that once a story becomes valuable, there is pressure to keep it interesting. A solved mystery sells fewer return expeditions than an unsolved one. A natural formation may be scientifically useful, but a possible sunken UFO gets more clicks. This is not a deep flaw in one team or one newspaper. It is part of how attention works. The public rewards mystery, and media outlets learn very quickly which version of a story makes people lean closer. At the same time, the mystery persists because even skeptical people can understand the appeal. It is not hard to see why the anomaly fascinated so many. The ocean is still one of the great unknown spaces on Earth. We live on a planet covered mostly by water, yet most people experience the sea only from its surface or shore. Underwater landscapes remain hidden, and hidden landscapes invite imagination. A strange shape on the seafloor seems to offer proof that our familiar world still has secret rooms. Even if the object is natural, the feeling behind the mystery is real. People want to know that the world is not completely catalogued. They want the map to have a few blank corners left, preferably somewhere cold, deep, and difficult to reach. There is also a deeper reason this particular mystery endures. It allows wonder without requiring full commitment. Person can say, "I know it is probably natural, but it is still strange." That is a comfortable position. It lets curiosity remain open while still respecting the evidence. The Baltic Sea anomaly does not force a person to choose between total belief and total dismissal. It sits in the middle and permits a softer kind of interest. You can enjoy the story as a mystery while accepting that geology is probably responsible. You can be skeptical of UFO claims and still find the image fascinating. You can think the wild theories are unlikely and still want someone to map the site more clearly. That middle ground keeps the story alive in a more durable way than pure belief would. Some mysteries burn brightly and then collapse when one clear fact appears. The Baltic Sea anomaly has lasted because it is not built on only one claim. It has layers. The sonar image is one layer. The divers are another. The samples are another. The equipment stories are another. The geology is another. The media coverage is another. The internet comparisons are another. Even if one layer weakens, the others remain. If someone says the sonar was poor, another person says the divers still found it strange. If someone says the samples were ordinary rock, another person says they may not have sampled the real object. If someone says glaciers can explain the shape, another person says the shape is still too unusual. The mystery survives by shifting weight from one part to another, like someone trying to carry too many shopping bags but somehow refusing to make 2 trips. This does not mean every objection is strong. Many are not. But mysteries do not need every part to be strong. They need enough unresolved feeling to remain interesting. The Baltic Sea anomaly has that. It has enough evidence to be real, but not enough public clarity to feel finished. It has enough expert explanation to be probably natural, but not enough dramatic closure to satisfy everyone. It has enough distance to remain difficult, and enough visual shape to remain memorable. That is a very stable recipe. The phrase, "scientists still can't explain," should be handled carefully. In the broadest sense, scientists can explain the anomaly as likely natural. In the narrower sense, the exact history of the formation may not be fully proven in public detail. Those are different claims. A good script should not pretend that experts are helpless in front of the object, staring into the sea while dramatic music plays and someone drops a clipboard. The more accurate point is that the anomaly has not been publicly explained in a way that closes every question for every listener. That is not quite as sensational, but it is more honest. It also makes the story more interesting, because it shows how mysteries can continue even when the strongest explanation is already on the table. The anomaly refuses to sink quietly because it is not only a thing on the seabed. It is a story about how people handle uncertainty. Some run toward the most exciting answer. Some run away from mystery altogether and dismiss it too quickly. Some hold both wonder and caution together, which is harder but usually healthier. The Baltic Sea anomaly gives each kind of person something to do. Believers can point to the shape. Skeptics can point to geology. Explorers can point to the need for better surveys. Storytellers can point to the strange mood of a dark object under cold water. Everyone finds a handle, and the mystery keeps being lifted again. Perhaps that is why it has lasted longer than many other modern anomalies. It is not simply asking, "What is this object?" It is asking, What do we need before we feel satisfied? A likely answer, a perfect answer, a photograph, a sample, a government statement, a famous scientist with a laser pointer, a diver tapping the surface and saying, "Definitely rock." The answer will differ from person to person. Some people are satisfied by the geological explanation. Others want more. Some will never be satisfied unless the answer matches the version they first loved. That is not just a Baltic problem. That is a human problem, and a very old one. In the end, the mystery's survival may say more about us than about the object itself. The seafloor feature is probably not doing anything dramatic. It is not posting updates. It is not trying to confuse us. It is simply there, shaped by whatever processes shaped it, resting beneath water and sediment. We are the ones who keep returning to it. We are the ones naming it, comparing it, arguing over it, and turning it into a symbol of the unknown. The anomaly has become a mirror for curiosity. Some people see evidence of hidden technology. Some see a natural formation. Some see a failure of public science communication. Some see a reminder that Earth still has places we do not fully see. And that may be the most useful way to understand why it refuses to disappear. It is not because the wildest theories are strong, it is because the mystery is shaped like something we need. A small reminder that even in an age of satellites, global maps and instant searches, there are still objects in dark water that do not explain themselves on command. There are still places where the first answer is incomplete, the image is unclear, and the careful work of knowing takes longer than the first rush of wondering. So the Baltic Sea anomaly remains suspended between fact and fascination. It is probably natural. It is certainly real as a seabed feature. It is not proven to be a craft, ruin, weapon, or machine. But it is also not just a solved footnote in the public imagination. It is a shape that arrived through sound, became famous through suggestion, and stayed alive because the sea kept enough of its details hidden. That is a difficult combination to sync. And as the story drifts toward its final quiet turn, the object becomes less important as a possible machine and more important as a lesson. It shows how wonder begins. It shows how evidence can be stretched. It shows why science needs patience and why mystery needs humility. It shows that the unknown is not always a doorway to something impossible. Sometimes it is a doorway to better questions, better tools, better maps, and a clearer understanding of how easily the mind can turn stone into story. So after following the sonar image, the return dives, the theories, the rock samples, the ice, and the long history of the Baltic Sea floor, we are left with a mystery that is quieter than it first appeared, but not empty. The Baltic Sea anomaly may not be a crashed craft. It may not be a lost temple. It may not be a secret weapon, a machine, or anything made by hands at all. The strongest explanation is still that it's probably a natural formation, shaped by rock, ice, sediment, and the long physical history of the region. But that does not make the story worthless. In some ways, it makes the story more useful, because it shows us how mystery actually works when the lights are dim, the picture is unclear, and the human mind is asked to wait before deciding what it sees. At the beginning, there was only an image made from sound, a sonar return from a cold seabed in the Gulf of Bothnia. It was not a photograph. It was not a direct look at an object in bright daylight. It was an echo map, a translation of the seafloor into shapes and shadows. But it was enough. Enough to make experienced explorers look twice. Enough to make viewers around the world lean closer. Enough to make people compare it to a spacecraft, a ruin, a platform, a crash site, and all sorts of things that had much more drama than a glacial deposit. That first image carried the whole story forward, not because it proved something impossible, but because it left room for possibility. And room for possibility is often all a mystery needs. That may be the first thing the anomaly teaches us. Wonder often begins in the gap between what we see and what we know. If we know too little, we imagine. If we see too little, We complete the picture ourselves. A vague shape becomes a structure, a dark mark becomes a trail, a hard surface becomes a floor, a broken ledge becomes a step. It is not because people are foolish, it is because the mind is always trying to organise the world. It wants patterns, it wants causes, it wants stories that make sense. Most of the time, that habit helps us. It lets us recognise faces, read signs, follow paths, and avoid walking into furniture in the middle of the night, usually. But the same habit can also turn a natural formation into something that looks designed, especially when the formation is deep underwater and only partly visible. There is nothing wrong with the first moment of wonder. In fact, it is one of the better parts of being human. Someone sees something strange and says, "Wait, what is that?" That question matters. It sends people back to the site. It encourages better surveys. It makes people learn about sonar, diving, geology, glacial history, and the hidden landscapes below the sea. The problem begins only when wonder refuses to share the room with caution. When a question becomes a conclusion too quickly, the mystery stops being explored and starts being decorated. Soon the object has engines, chambers, powers, or secrets that the evidence never showed. The Baltic Sea anomaly reminds us that curiosity is strongest when it stays curious for a little longer. It also teaches us that a natural explanation is not the same as a boring explanation. That is a mistake we make often. We treat natural as if it means plain, simple, or disappointing. But the natural story here is enormous. It involves ice sheets covering northern Europe, pressing down on the land, grinding rock, carrying stones, melting, retreating, and leaving behind a sea floor that still carries the marks of that long process. It involves a sea that changed shape through time, coastlines that moved, land that is still rising after the weight of ancient ice disappeared, and stones that may have travelled inside or beneath glaciers before settling into place. That is not boring. It is just slower than a crash. It does not arrive with a flash. It arrives with pressure, cold, and thousands of years of change. A spaceship would make a louder story. A ruin would make a more human one. A weapon would make a darker one. But ice and stone make an older one. They remind us that Earth can create forms that look almost intentional without intending anything at all. A glacier does not know it is leaving a mystery. A rock does not know it is breaking along a clean line. Sediment does not know it is hiding one edge and exposing another. Sonar does not know it is making a shadow look like a wall. The human mind arrives later and says, "This looks like something." The world quietly replies, "It is something, but perhaps not the thing you first thought." That is a useful lesson far beyond the Baltic Sea. Many mysteries begin with a real observation, a light in the sky, a strange sound, a shape in a photograph, a mark in the ground, a reading on an instrument. The observation may be real, but the first interpretation may be wrong. The difference between those two things is important. Saying the anomaly is probably natural does not mean the sonar image was fake. It does not mean the explorers saw nothing. It does not mean the divers imagined everything. It means the best explanation for the available evidence does not need an artificial object. A mystery can be real in one sense and mistaken in another. The image was real. The seafloor feature is real. The story built around it may have grown larger than the evidence could hold. The anomaly also shows why some mysteries stay alive even after a likely answer appears. People do not always want the most probable answer. They want the answer that feels equal to the first feeling of surprise. If the first feeling was huge, the explanation needs to feel huge too, or it seems unsatisfying. A glacial formation may be correct, but if someone first imagined an ancient craft at the bottom of the Baltic, rock can feel like a letdown. That feeling is understandable, but it is not a good way to judge evidence. Truth does not always have the same emotional size as the mystery it replaces. Sometimes the answer is smaller, quieter, and more ordinary. Sometimes it is a rock. Sometimes it is a shadow, sometimes it is the angle of a scan, and sometimes, if we are patient, the ordinary answer opens into something large in a different way. There is comfort in that, especially at this slower hour. The world does not need every mystery to become a miracle in order to remain interesting. A rock shaped by an ice sheet can be interesting. A sonar image that fooled millions can be interesting. A public reaction that reveals how humans see patterns can be interesting. A seafloor that remains difficult to map can be interesting. We do not lose wonder when we lose the wildest theory. We only lose one costume that wonder was wearing. Underneath it, the curiosity is still there, perhaps better dressed for the weather. And the Baltic Sea is very much a weathered place. It is cold, enclosed, historic, and difficult. It has held wrecks, trade routes, military remains, fishing grounds, and quiet geological records. It is not strange that people imagine secrets there. The sea has always encouraged that. From the surface, water looks simple. A grey sheet under a grey sky, a few waves, a line of horizon. But below that surface, the world changes. Sound behaves differently. Light fades. Distance becomes hard to judge. Objects lose colour. Surfaces appear in fragments. A diver's lamp catches one patch of rock, then another, and everything outside the beam remains hidden. In such a place, certainty has to work harder. That is another lesson. Some environments naturally protect uncertainty. Underwater, especially in cold and dark conditions, evidence is harder to gather. It takes boats, divers, instruments, money, weather, planning, and time. A dramatic claim can travel across the world in minutes. A careful survey may take months or years if anyone funds it at all. This imbalance helps mysteries survive. The story moves faster than the method. By the time a geologist says this is probably natural, the imagination has already built rooms inside the object and installed lighting. Very nice lighting, probably, though not supported by the data. Still, we should not treat imagination as the enemy. Imagination is why people care. Without imagination, the sonar image might have been ignored by everyone except a few specialists. With imagination, people learned about the Baltic, sonar, glacial geology, diving conditions, and how difficult it is to interpret the seafloor. The task is not to remove imagination. The task is to keep it from pretending to be evidence. Let imagination ask the first question. Let science check the answer. Let wonder open the door. Let caution look at the floor before stepping through. That is a better way to move through mysteries, and perhaps through ordinary life as well. The Baltic Sea, Anomaly also reminds us that the unknown does not always point away from Earth. Very often it points deeper into Earth, down into the seabed, back into the Ice Age, into the behaviour of rocks, sediment and water, into the limits of our tools and the habits of our perception. It is tempting to look at a strange object and imagine distant stars, lost civilizations or hidden technology. But sometimes the more useful journey is local. What happened here? What shaped this place? What kind of stone is this? How did the sea change? What did the ice leave behind? These questions may not sound as flashy, but they lead to real knowledge. In that way, the anomaly becomes less of a locked box and more of a reminder to look carefully. It asks us not to confuse unclear with impossible. It asks us not to confuse unusual with artificial. It asks us not to confuse a story we like with a conclusion we have earned. Those are simple lessons, but they matter. The modern world gives us images constantly, and many of them arrive without context. A cropped photograph, a short clip, a dramatic headline, a strange shape circled in red. The Baltic Sea anomaly is one case, but the habit applies everywhere. Before deciding, we can ask what the image actually shows, what it does not show, who interpreted it, what information is missing, and what simpler explanations already exist. This is not a cold way to live, It is a calmer one, and calm is useful here. The anomaly does not need fear, it does not need shouting, it does not need to be forced into certainty. It can rest as it is, a real feature on the Baltic Sea floor that looked strange in sonar images, inspired many theories, and is most likely natural. That sentence may not make the front page of every mystery magazine, but it is honest. It leaves room for future surveys without pretending that every question is equal. It allows the wonder to remain without letting it run loose through the house knocking over lamps. So where does that leave us after this long quiet journey beneath the Northern Sea? It leaves us with a shape in the dark, but also with a better understanding of the dark itself. It leaves us with explorers watching a screen, divers moving through low visibility, geologists thinking about ancient ice, and people around the world trying to decide what a blurred circle means. It leaves us with the knowledge that the seafloor is still difficult, still underexplored, and still capable of surprising us. It leaves us with the reminder that not every surprise is a secret machine. Some surprises are made by natural forces moving slowly enough that we forget how powerful they are, and perhaps that is enough for tonight. Not every mystery needs to end with a door opening. Sometimes it ends with a more careful look. Sometimes it ends with a better question. Sometimes it ends with the quiet acceptance that the world is still full of things we do not see clearly at first. The Baltic Sea anomaly may remain famous because it looked like something it probably is not. But even that has value. It shows how easily wonder begins, how quickly stories form, and how patiently truth asks to be checked. If you're still listening, maybe the room around you has grown a little quieter. Maybe the day has loosened its grip. Maybe, somewhere far from you, the Baltic Sea is lying under the night, its surface dark, its bottom colder still, the famous formation resting where it has rested for a very long time. No engines humming, no ancient door waiting to open, no need for drama, just stone, sediment, water, and the old marks of ice, holding their place while people above continue to wonder. And before we leave it there, think back to the question from the beginning. Where are you listening from tonight? Are you near the sea or far from it? Is it late where you are, or still early enough that the world outside has not gone fully quiet? It is a small thing, but it connects you to the same habit that made the anomaly famous in the first place. The wish to place ourselves in the world, to look outward, to ask what is there, and to feel for a moment that the familiar planet beneath us still has hidden corners. If this journey through cold water, sonar shadows, strange theories, and ancient ice brought you a little calm, I would be grateful if you liked the video and subscribed. It helps this quiet space reach other people who enjoy slow mysteries, careful science, and stories that do not need to shout in order to be interesting. Share it with someone who likes unexplained places, or with someone who needs a gentle reminder that wonder and reason can sit together peacefully, like two tired travellers on the same boat. For now, let the Baltic keep its shape. Let the object be stone if it is stone. Let it be a question where the evidence still leaves small gaps. Let it remind us that mystery does not disappear when we become careful. It becomes clearer, steadier, and sometimes even more beautiful in the ordinary sense of that word. Not magical, not impossible, just real, old, difficult to reach, and worth understanding. Sleep well, fellow traveller, wherever you're listening from tonight. The sea can keep its silence a little longer, and so can the unanswered things.